Good evening, everyone. Good to be back after a month. For the people in the US and Indians as well, happy Thanksgiving, right? Just a quick update before we start our sessions. I think GMAT Club, um, they're very, very proactive, during this time of the year. So they have organized something called 12 Days of Christmas. It's their annual winter GMAT competition, which goes from December 15th to 26th. A fun competition. You would be a part of a team. You solve questions, you write explanations, and you win points. And like you see there, there's a $30,000 prize fund. Plus, there are some courses as well that you can win, plus packages for admission consulting. So it's you can integrate the fun aspect of working with questions along with your prep as well. Okay, so please do check it out, right? And know, I hope this is a great success as well, right? All right, let's start. Let me share my screen quickly for those who have logged in. You can quickly type in the chat window what normal problems you face on the time and work topic. So I will try to cater to those issues as well as we move forward. I haven't touched the topic, was waiting for this video. How to form equations. Yes, so before we start, the time and work topic, right? When I tutor test takers in my program, I normally keep this topic towards the end of the word problem module. The reason for that is because a question on time and work will include percentages, will include the concept of ratios, and more importantly, it requires also a very good stronghold in terms of how to read, process, visualize pieces of information, and more importantly, organize those multiple pieces of information in a structured approach, and then use those pieces of information to get to what the question's asking you, right? So it's basically, and a culmination of what all structures and what all skill sets you require for the entire word problems module. This is a topic that requires that does not have any concept other than using rate is equal to work by time, the formula, right? But a lot of structures, a lot of organization, a lot of reading and comprehending involved. So I am going to deal with that. For those who said how to create equations, I am going to deal with that during my discussion. Okay, so without further ado, let's quickly start with the concept. When it comes to the topic of time and work, yes, everything will relate or tie back to the formula rate is equal to work divided by time. That is the fundamental formula that you're going to use to build any kind of question in this topic. But how I look at it, right? And this is something that I learned in school. It was something that my mother taught me when I had an issue with this topic sometime in sixth grade. I came back home and I said I did not understand it. So the way she explained it is what I held on to, and that helped me also understand the conventional process of working as well. So I'm going to give you how I've learned the topic. I may tweak it here and there as well based on my understanding of the GMAT as well. So when I look at a time and work question, right, the first thing I ask myself is what kind of time and work question is it? There are two kinds of work that people will do. The first is independent work, and the second is group work. If you understand and create a good bifurcation between these two, you will work with these two question types slightly differently. What is independent work? Independent work is when objects work with different rates. For example, you may have multiple objects in the question. They may work individually, may work together, but they all work with different rates. Group work is when objects work with the same rate. Basically, the rate is constant here. A simple example would be 10 people can build 20 houses in 40 days. So, when I speak about 10 people building 20 houses in 40 days, I am not giving you any information about the rate of every individual person. So, the assumption there is that the entire group of 10 people, everybody who's part of that group, works at a constant rate. So, if the rate is not categorically mentioned about the objects, you consider them and they're working in the form of a group to complete any task, it would be characterized as a group work question. But if you have individual rates given, or they tell you that A and B together take 10 days to finish a piece of work, B and C together take 12 days. You see, they're giving me different timelines that people together take to finish the work. So obviously the rates at which the people would work would be different. That would be categorized as an independent work question. Okay. So I want you to first try to make a clear demarcator between independent work and group work, right? Because if you do that from the outset, we can follow a simple structure to work independent work questions. You can follow a simple structure for working with group work questions. To be truthful, you can use the independent work structure for group work as well. You can use group work for independent work, but it becomes too convoluted at some points. So bifurcating it would be beneficial. So remember, independent work, group work. Independent work, objects are working either together or individually, but they will have different times. And obviously, if there's different times, there's different rates. Group work, objects work together at the same rate. The rate will always be a constant. Okay? That's the first thing that I want to speak about. We're going to look at each one of these works individually. We're going to start with the concept of group work first. Whenever you see that objects are working in the form of a group and the rates are considered to be constant, instead of going with the classical formula of rate is equal to work by time, the better way to work with group work questions is to use what you would have studied in school, something called a unitary method of working. And this was the method that I had trouble with because yeah, teacher did not explain it well, or maybe I didn't understand it well. But the unitary method of working, also called the method of proportions, is the best process that you can use for group work questions. And not only group work, you can use unitary method. The process of comparisons, the process of proportions is also used in percentages, right? For example, if you say 40 is 100%, 60 is how much, right? That is a concept of proportions. That is unitary method. If 20 men can build 40 houses, 40 men can build how many houses, right? If 20 men can build 40 houses in 80 days, then 40 men can build 20 houses in how many days, right? So when you get questions like that, those are very indicative of unitary method, a concept of proportions where you're comparing quantities with respect to each other and you're trying to use that comparison to figure out the unknown, right? This concept of proportions is also super important because it forms the crux of conversions, unit conversions questions. Normally, unit conversion questions, there will be a smattering of one or two unit conversion questions in your entire 21 question set. A unit conversion question requires you to understand the units that are given to you, requires you also to ensure that every quantity is maintained across a standard unit, and it requires you to use the unit conversions to set up a proportion to figure out what the question is asking. So don't limit your thinking of unitary method only in terms of group work, even though I'm utilizing it here. It can be used for ratios, it can be used for Percentages, it can be used for unit conversion questions, it can be used for group work questions. Basically, whenever you're comparing quantities that have a specific relationship, right? So whenever you see a group work question, the best way to approach it is to use the unitary method of working. So let's understand that unitary method, the concept of proportions, and then let's move forward. Now, let's take a simple example. Let's say we have monkeys and we have bananas, right? We have 20 monkeys require 40 bananas. You require 40 bananas to feed 20 monkeys, right? So I'm giving you that relationship. And I'm asking you now, if 20 monkeys require 40 bananas, 25 monkeys require how many bananas? Now, what most of y'all would tell me is, Aditya, it's very simple. I can do it in one of two ways. 20 monkeys can eat 40 bananas. So one monkey, I can find out how many bananas one monkey eats. So one monkey eats 40 divided by 22 bananas. So 25 monkeys eat 50 bananas. Some people would use that processing and work. Some people would say, I just cross multiply, because in school they told me to cross multiply, right? Both ways are fine, but let's dive a little more deeper and understand what the concept of proportions are. Because if you understand the concept of proportions, whichever quantities are compared, you will be able to figure out how you need to how you need to use the data points, whether to cross multiply or multiply in a straight line. You don't need to sit and work every time with one monkey, one banana, and all of that working, right? If you understand the concept of proportions, you would get your answer to such questions in one step. But you'll have to use a little bit of common sense to figure out what proportion runs between two quantities. So let's work with this, right? Let's understand this logically. 20 monkeys need 40 bananas, 25 monkeys. So the number of monkeys is increasing. So if I increase the number of monkeys, logically, I will require more than 40 bananas. So when one quantity increases, the other also increases, or one quantity decreases, the other also decreases. That is, the arrows are in the same direction. That proportion is what we refer to as a direct proportion. And the simple rule of thumb is, if the quantities given to me are directly proportional, I will always cross multiply. All right. So the only question you need to ask yourself is, how are the quantities that are being compared related to each other? Yes. I'm going to cross multiply. 20x is equal to 25 times 40. So x would be 25 times 40 divided by 20, which would give me the 50. And you'll realize, if I break it down to its understanding of how to work with that question with one monkey, you told me 20 monkeys eat 40 bananas. So one monkey would eat 40 by 20. You see, this 40 by 20 would give me how many bananas one monkey would eat. And that multiplied by 25 would give me the total. Right? So the cross multiplication by default takes care of that working, where you make one quantity to a single unit measure. Right? But if I use the same numbers, but I change the quantities that I'm comparing, let's say I have men and I have days. Right? 20 men take 40 days to finish a piece of work. So 25 men take how many days? You see, I'm using the same quantities, I'm using the same numbers, but I'm changing the quantities that I'm comparing. Now, here, if I look at it logically, 20 men take 40 days to finish a piece of work. Some people would just directly cross multiply and give the answer as 50 as well. But if you think about it, in a common sense standpoint, if you answer 50, you're telling me that more number of men will take more number of days, which ideally should not be the case, right? If there are more number of men Provided all the men are working at a constant rate, it should take you lesser time. So whenever you have questions like this, make a comparison. 20 men, 40 days. 25 men, I'm increasing the number of men, so the number of days must reduce. So when one quantity increases, the other decreases. Or when one quantity decreases and the other increases, when the arrows are in different directions, then that proportion is what we call an inverse proportion, right? And whenever you see that you have quantities that are inversely proportional with respect to each other, you always multiply in a straight line. I'll explain the logic to this as well. You multiply in a straight line. So what do you write here? 25x is equal to 20 times 40. You see, I'm multiplying in a straight line and equating it. So x would be 20 into 40 divided by 25. Simplifying, 5 5s are 25, 5 4s are 20, 5 1s are 5 8s are 40. That would give me a total of 32 days. Now, what's the logic behind multiplying in a straight line here? If 20 men take 40 days to finish a piece of work, one man will not take 40 divided by 20, like how we when we did monkeys and bananas, right? One man would take 40 times 20 days, right? You're multiplying those two. You're not taking the 20 and you're not taking the 40 and dividing it by 20 like what we did in the monkeys and bananas. If 20 men take 40 days to finish a piece of work, one man would obviously take a lot more time, right? That would be 40 times 20 days. So obviously one man takes 40 times 20 days, 25 men should take 1/25 of that time, right? So divided by 25. So instead of doing all of this, all I'm saying is if you see that the proportion between the quantities are inverse, you always multiply in a straight line. Got it? Any doubts until here? Because I'll be using this as a ground fundamental to build on certain things. Guys, like I mentioned, I'm going to speak about time and work, exclusively in this session. I will not be able to fit in speed, distance, time as well. Okay, it's too vast a topic. So if you want, maybe we can have a part two where we discuss speed, distance, time, a little later. That would be my last session, right? But I'm not decided on that. I cannot do both speed, distance, time, and time and work. So we're only focusing on time and work here. Correct? Okay, any doubts on what we've done so far? Did you understand the concept of proportions? How did I get them to be direct? How did I get them to be inverse? Cross multiplication and also multiplying in a straight line? Okay. Now, what I want you to understand, right, is when you get a comparison between two quantities, always ask yourself commonsensical questions to figure out the proportions, right? For example, if I give you, any formula, by the way, right, even your formula of rate is equal to work by time, even your formula of speed is equal to distance by time, um, even your Newton's second law, if you remember it, right? If you don't remember force is equal to mass into acceleration, then forget I said it, right? But most of the formulae that you have in physics, chemistry, and math are derivatives of proportions, right? For example, if I take rate, work, and time, we have three quantities here. So what we do normally to generate this formula, and if anybody in school thought about why is rate equal to work on the numerator and time on the denominator, why not time on the numerator, work on the denominator, right? If you ever thought of why a formula was the way it is, instead of only rote learning it, you would realize that any formula is derived using the concept of proportions. And here we have three quantities: rate, work, and time, right? And remember, rate is speed in the speed, distance, time topic. Work is distance, time is time itself. So whatever I'm doing here carries forward in a speed, distance, time topic as well. Now, whenever you're comparing quantities like this, what we do is we always make a comparison, because proportions are always defined between two quantities, right? So we always make a proportion between two quantities, keeping the other quantities that also present constant. So if I'm comparing the rate and the work, keeping the time constant, let's say everyone is working for a fixed time of 1 hour. If I increase the rate at which a person works, obviously more work is going to be done. So rate and work are what we call directly proportional, right? And we write down the proportionality symbol like that. Similarly, if I compare rate and time, provided the work is constant, provided the work is constant, let's say for a fixed 100 units of work, if I increase the rate at which I work, I would obviously take lesser time, right? So rate and time are always inversely proportional. And we write the inversely proportional with the proportionality symbol, but we flip around the time. So it's 1 divided by time. And this is how you get to that formula. We replace the proportionality symbol with an equality and we put a constant. I'm not going to get into physics at this point. So that is why we have rate is equal to work divided by time, work on the numerator and time on the denominator. And that is why speed is equal to distance divided by time, distance on the numerator and time on the denominator. So anytime you have questions like this, right, it doesn't matter what the quantities are, right? In this topic, we normally pertain ourselves to rate, work, time, maybe days, hours, efficiency, right? Those kinds of quantities. But to be truthful, any kind of quantity that you have, even force, mass, acceleration, density, mass, volume, you can always connect them through proportions, right? Keeping everything else constant. And that's what we are going to try to do, in the process of the unitary method, right? Direct proportions, remember, direct proportions always cross multiply, inverse proportions multiply in a straight line, right? For that, you have to ask yourself, what is the proportion between the two quantities that I'm comparing? If I increase one quantity, what happens to the other? If I decrease that quantity, what happens to the other? Okay. So you tell me, right? If I ask you to compare days and hours with respect to each other, keeping everything else constant, how would days and hours be related to each other? Would they be directly proportional or would they be inversely proportional? What do you think? Days and hours, if I'm comparing the two, would they be directly proportional or would they be inversely proportional? So this is where asking yourself questions in your head is important. See, think about it like this, and always when you're trying to find the proportion between quantities, no, you're trying to find proportion between quantities. Use a simple example. Imagine that all of you are preparing for the GMAT. Okay, you are preparing for the GMAT. So the work that you all are doing is constant, right? If I increase the number of hours that I put into a project like the GMAT or some project at office, if I increase the number of hours, what is going to happen to the number of days? If I increase the number of hours, remember the work is constant, the work is not going to change. So if I increase the number of hours, what happens to the number of days? It's going to reduce. More hours means I'll finish things faster. Remember, assuming everything else is constant, the efficiency, work, everything else is constant. My only focus is on comparing days and hours, keeping everything else constant. So use a simple, realistic example. You're on a project, all of you are working on a project, you'll have a specific timeline, and you're going to put in 8 hours per day to finish that project. If you increase the number of hours, provided your efficiency remains the same, right, the number of days will reduce. So, what is important here for you to understand is for you to take a step back, look at the quantities that are being compared, and ask yourself those commonsensical questions. What happens if I increase one? What happens to the other? What happens if I decrease one? What happens to the other? But if the hours I take to complete the work increases, the number of days will also increase subsequently. See, the work is a constant, right? So if I increase the number of work, if I increase the number of hours to complete the work, then the number of days of finishing the work would reduce. No, how would the days increase? Look at it from the perspective of a question, right? If you're working on a project, you're increasing the number of hours, right? You're going to finish the project in 20 days if you work on it for 4 hours. Now think logically. If you increase the number of hours to 6 hours, you will take lesser days to finish that project, right? I want you to think about this logically from a perspective of a real life scenario. Okay? Let's take another example. What if I ask you to compare time and efficiency, keeping everything else constant? If I increase the efficiency of the people who are working, what is going to happen to the time? If I decrease the efficiency of the people who are working, what is going to happen to the time that I would take to complete the project? Think about it, guys. You need to ask this and you need to understand this logically, okay? If I decrease the efficiency at which a person works, what is going to happen to the time? Yes, it is going to increase. If I decrease the efficiency per person, the time would increase. Same way, if I increase the efficiency, the time would reduce. So what I want you to understand here is when you're comparing quantities, it can be any quantity that can be compared. Normally on this topic, they would, compare it with rate, work, time, efficiency, maybe, you know, the amount of food per given per person. But any kind of quantity that are being compared to each other, any kind of quantities that are being compared to each other, you need to look at it from a logical perspective. Ask yourself, keeping everything else constant, if I reduce one, what happens to the other? If I increase one, what happens to the other? Right? That will give you the kind of proportion that runs. And if it's a direct proportion, remember, cross multiply. If it's an inverse proportion, always multiply in a straight line. Got it? Okay. Let's take a simple example. Okay, I'll just off the bat try to create an example. Let's say 6 machines take 18 days. 6 machines working together at the same constant rate take 18 days to finish a piece of work. How many additional machines will be required to finish the work in 12 days? I'll repeat the question. I want you to try it out. I'm just creating a question, off the top of my head. 6 machines take 18 days. 6 machines working together at the same constant rate take 18 days to finish a piece of work. How many additional machines will be required to finish the same work in 12 days? I want you all to try it and give me an answer. And then we'll make it a little more complex. Guys, remember, I'm asking you how many additional machines. Okay, so don't make the bonk on your head error of picking 9, because then you've done all the hard work and you picked the wrong one, right? Yes. So how I would work with this again: 6 machines, 18 days. So 12 machines, how many days? So I know if I reduce the days, if I want to reduce the number of days from 18 to 12, I need to increase the number of machines. So the two quantities are inversely proportional, and they're inversely proportional. We multiply in a straight line. So 12x is equal to 6 times 18. So 6 ones are 6 twos are. So x would be 9. The question was how many additional machines. So 6 machines previously, 9 now. So 3 additional machines would be my answer. Correct? Okay. Let's make it a little more complex. Normally, proportions are defined between two quantities, like what we did here, right? Rate work, rate time, time hours, machines days, machines hours. But what if I have more than two quantities that are being compared? Something like this. Let me give you a question. 24 men, again, I'm creating a question off the top of my head. 24 men can bind 720 books in 6 days. So 12 men can bind 1080 books in how many days? See, I can craft any kind of question I want. I can give you a question where three quantities are being compared. I can add one more if I want. 24 men, 720 books, 6 days, working 3 hours a day. 12 men can bind 1080 books in 9 days, working how many hours a day? You see, I can add how many ever quantities I want. But the process that we use is pretty much the same. We'll work for three, and then maybe we'll look at an example of four as well. What do you do with four? So I'll repeat the question. 24 men can bind 720 books in 6 days. So 12 men can bind 1080 books in how many days? Now, normally, when people work with such a question, they'll find out one man, one book, 1 day, and then they will try to do the calculations. The problem with that process is if I go on adding more quantities to the side, it would be very difficult for me to find one man, one book, 1 day, 1 hour, right, and do the calculations, correct? Instead, we use again the concept of proportions. Exactly what we did to derive this formula, right? What did we do for rate is equal to work by time? We said we found the proportion between rate and work, keeping the time constant. We found the proportion between the rate and time, keeping the work constant, right? We use the rate as a reference with the work and with the time, keeping everything else constant. And then we, based on the proportions, we got to a relationship and we set up the formula there, right? I'm going to do exactly the same thing here. So whenever you have more than two quantities that are being compared, the first thing you do, exactly what we did to derive that formula. First, select two quantities at a time such that one is always the unknown. I would always select, remember, proportions are always defined between two quantities. Select two quantities such that one is always the unknown. The unknown quantity that you need to solve for acts as a reference. Here, rate was a reference. Here, days will be a reference because that's what I need to solve for. Select two quantities such that one is always the unknown. Second, find the proportion between the two quantities. Okay, let's do it as I'm writing the points on the right hand side of the screen as well. So I have men, I have books, I have days. I'm going to select two quantities at a time such that one is always the unknown. So I'm going to pick men and days first, keeping books constant. And then I'm going to take books and days, keeping men constant. So I'm going to take men and days first, keeping the books constant. So 24 men take 6 days to finish a piece of work. 12 men, the number of men is reducing. Remember, we are not considering the books at this point. So 24 men, we are only comparing men and days. 24 men take 6 days to finish a piece of work. 12 men, so the number of men reduce. Obviously, I will need more than 6 days. So what is the proportion between men and days there? The proportion is inverse proportion. And what do you do for an inverse proportion? You multiply in a straight line. 24 times 6 is equal to 12 times x. So you get x as 24 times 6 divided by 12. Just write that down. Don't worry about the x. Write down what is on the numerator, write down what is on the denominator. Don't simplify, don't solve. Leave it as it is. Remember, what we need to do is we need to use proportions to figure out what quantities go on the numerator and what quantities go on the denominator. So 24 times 6 is equal to 12x. So x would be 24 times 6 divided by 12. I'm only writing 24 times 6 divided by 12. I'm not simplifying it. I'm leaving it as it is. Now I'm going to go to books and days. To bind 720 books, I take 6 days. Remember, for me, the men is constant now. To bind 720 books, I take 6 days. If I want to bind 1080 books, the number of books is increasing. I will need more than 6 days. So the proportion between books and days is a direct proportion. And in a direct proportion, you're always going to cross multiply. So 720x is equal to 1080 times 6. So x would be 1080 times 6 divided by 720. Again, just write down, use the proportion to write down what quantities are on the numerator, what quantities on the denominator. Exactly what we did with rate, work, and time, right? We saw rate is directly proportional to the work, keeping the time constant, and rate is inversely proportional to the time, keeping the work constant. Then what did we do once we found the proportions? We clubbed both these equations together, and whatever quantity we used as a reference, we used it only once in the overall representation of that entire equation. So we said rate is equal to work divided by time. That's exactly what we do here as well, right? We have found the proportions between men and days. We've written that down here. We found the proportion between books and days. We've written that down here, right? So you find the proportion between the two quantities, write down the proportions. Then after you find the proportions, we club everything together. Club all the quantities together. And since we have considered this unknown quantity days twice, it's like rate is directly proportional to the work, rate is inversely proportional to the time. When we clubbed those two quantities together, we wrote the rate only once. So here we have compared men with days. We are also comparing books with days. So when I'm clubbing everything and I'm writing down all my quantities on the numerator and the denominator, I've considered this quantity days twice, but ideally I can only consider that quantity once. So what should I do? I should have only 1, 2, 3, 4, 5 quantities in my calculation. I have 1, 2, 3, 4, 5, 6 because I've used the days twice. So what am I going to do? I'm going to remove the excess. Whatever quantity I have as an excess will always be on my numerator, and remove that excess quantity of your unknown. Remove the excess. And what you're left out with is the proportions of all the three quantities taken together. So club all the quantities together and remove the excess. Once you do that, you can now go ahead and solve, simplify, and get to your answer, right? So I can remove the zeros. 24 goes to 72 three times. 12 nines are 108. 3 threes are 9. That would give me 18 days, right? This is a step-by-step process of working when you have more than two quantities being compared. So even if you had four quantities, say instead of three quantities, I had four, I would still do the same thing. I would select two quantities at a time. One quantity always being the unknown. Keeping everything constant, I would write down the proportions of all the three quantities, right? I have four quantities being compared. So one with the unknown, the second with the unknown, the third with the unknown. I would write down the proportions of each, not simplify. Then once I've written the proportions between the quantities taken two at a time, I will club everything together on the numerator and the denominator, right? And once I club everything on the numerator and the denominator, since I have four quantities, I've utilized the unknown quantity three times. I can only utilize it once. I will remove two times the excess. Okay, I don't expect on the GMAT for you to get four quantities, but even if you get it, you know exactly what needs to be done. All right, so I'm putting in a process here that will work for every kind of question, whether you have three quantities being compared, four quantities being compared, five quantities being compared. Follow the same process. Yes, that's exactly what I'm doing here, Ara. So what you wrote directly is you use the concept of ratios and you set it up. I'm also using the same, right? But if I give you three quantities, Ara, then if I give you men, books, days, and hours, then your kind of equations will be slightly more difficult to work with and get to, right? So I'm giving you a process that will work exactly how many ever quantities that you have. All right. So this is what you do even if you have more than two quantities. Proportions are normally defined for two, but if you have more than two, you can always use this process and work. Right? I'm basically using a little bit of physics, okay, and general mathematics of how to derive formulae to work with here. All right. Okay. What doing 6 into 2 is equal to 60. 720 into 6. So now again, right? 720 divided by 6 into 2 is exactly what I'm doing here, no? So 720, right? So you see what you've written directly in one step. See, guys, one thing you have to understand as well when I'm working with concepts like this, and I keep telling you this as well. Think about it from my perspective, right? If I were to solve this question in a real life scenario, I wouldn't write all of these steps. I would just directly do exactly what equations you've done and work with. But you have to understand that solving and teaching are two very different things, right? Because if I'm in a process of teaching, I need to ensure that I cater to every test taker. I put in a process that works for every test taker, right? Even a test taker who's not so well versed of just creating the equations that way, right? So I'm putting in a process that works throughout, right? Irrespective of the complexity of the question, every test taker can use this process and work with. Got it? Yes. Okay. I'll also tell you why I'm particular about this process. When you go into questions, you'll see, how I link what I've learned here on questions. So any doubts on this? Any doubts on how I got to these and how I ended up getting my entire equation and worked? I've written the step-by-step process for people who are also new to this topic, right? So any doubts? I will explain again. The process exactly remains the same even when I have four quantities, five quantities, right? Remove the excess means I've compared the men and the days first, right? And then I've compared books and the days, right? It's like I've compared rate and work. Then I've compared rate and time individually. But I need all of them together, right? So if I need all of them together, if you're going to club these quantities together, you would only write the rate once, right? You wouldn't write rate, right? You would write the rate once, and then you would say rate is equal to work divided by time. So what I've done here is I've compared the men and the days and compared the books and the days. So I've considered that days quantity twice, right? So I can't consider that twice in terms of my calculation. So the days basically is that six, the data that six number, right? So when I'm putting everything together, since I've considered the days twice, I need to get rid of that extra quantity, right? And only work with the five quantities that are given to me. It's the same as what I did here, right? I did not write the rate twice, wrote it once, and I said the rate should be equal to work on the numerator, time on the denominator, right? Guys, I'm just using simple understanding of physics, how to derive formulae. Your Newton's second law of force is equal to mass into acceleration. If you remember it, if you don't know, no problems. Is also based on proportions, right? Force, if you're comparing force and mass, provided everything else is constant, force is directly proportional to the mass, right? Heavier the object, harder it is to move, right? You need more force for it to move. And force and acceleration, provided the mass is constant. Let's say we have a brick of 1 kg, fixed brick of 1 kg. If I want to make the brick move faster, I need to apply more force, right? So force is directly proportional to the mass, force is directly proportional to acceleration. That is how we get the formula force is equal to the mass times acceleration, right? So any formula is derived based on the concept of proportions. I'm just using that understanding to work with rather than, rote learn another formula and then set up equations based on that. I'm just setting it up based on proportions the way I've learned. Okay. All right. Any doubts, please ask me at this point, guys, because three quantities becomes a little, trickier. So if you master three quantities, you can do four, five, six. I don't expect them to give you so many. but normally 3 or 4 is what I can expect maximum. Any doubts on this? If not, we can move in to the first question that I have on my PPT. All right. Okay, I'm going in to my PPT. I have a good set of 20 questions here. All right, going to start with an easy one, quick, just a trial kind of question. I want you to take a minute or so, give it a shot, and give me an answer. Don't type in your chat. Don't type in the answers in the chat window, please. Just wait for me to ask you to type it in. Right? It influences others as well. Right? Give it a shot. Okay, I will take one question for quantities as well. There is a question anyway in the set of questions that I have, but I'll take a separate example. Okay. Congratulations, Reston Bot. Okay. 665 is a great score. All the best for your applications. I'm assuming since you're attending the session here that you're taking a retake. So right, I would still apply, right, and then also take the retake if I have time on my hands. Okay. Okay. You can start typing your answers in the chat window. Not a difficult one, to be truthful. Great. Okay. So I see all of you are giving me an answer. That's great. So the first thing that I would do, right, and like I said, I do this topic only at the fag end of my discussions of word problems because it requires skill sets of how to read, how to process, how to infer from data given to you. Not too difficult here. 5 machines at a certain factory operate at the same constant rate. If 4 of these machines operating simultaneously take 30 hours to fill a certain production order, so they told me that 4 machines take 30 hours to fill a certain production order. You see, when they tell me that 4 machines take 30 hours, the rate is constant, immediately I would go into a group work kind of process where I use the concept of proportions. If I'm going to use the concept of proportions, I need to set it up as a comparison, right? How many fewer hours does it take all 5 machines operating simultaneously to fill the same production order? So I have 5 machines. How many hours, right? So you remember, you need to find out how many hours will 5 machines take and then subtract it from 30 because the questions ask me how many fewer hours. So if I'm increasing the number of machines, I obviously have to reduce the number of hours because it would take lesser time. So the proportion here is inverse. I would quickly multiply in a straight line. So 5x is equal to 4 times 30. 5 ones are 5 6 are. X would be 24. So if it's 30 hours, it becomes 24 hours. Fewer hours would be 6 hours. My answer is C. Right? Easy question to start with, just to show you how I would use the concept of proportions here. Right? I'm assuming not many of you all will have doubts here. But any of you all will have what happens to the number of hours. Correct? And read the question carefully. For a couple of you all have given me 30, and ideally 24 is also a possibility here. right? If you don't read the question carefully. So if you've given me 24 as an answer, you've not read the fewer hours. Okay, so be a little careful, because these kinds of questions, low hanging fruit questions, will cost you on test day. Okay, let's go into the second. Okay, a more nuanced question, right? Again, I'll give you a couple of minutes. Try it out. Also, guys, if you can, hit the like button and let the algorithm do its work, it would be greatly appreciated. Okay, you can start typing your answers in the chat window, please. Guys, read the question. Read the question. Don't get so caught up in the working that you forget to read details of the question. All right? Just giving you a heads up. This is something you have to learn to do. Doesn't matter if you don't know the number of masons, right? Proportions can exist even with variables. So don't need to worry. Put put the masons as X and move from there. You can say, see, job is like a number, Priyanka. So if you can't look at it from a logical perspective, Priyanka, you can make a separate column for work, right? You can say that the work would be one. Now the work is twice, right? So the work becomes two for the second stage, right? Understood? So if you have an increase in job, make a separate column for job. If they give you efficiency, you have an increase in efficiency, make a separate efficiency. But ideally, what you should do, you should look at it from a logical perspective as well. Normally, when you increase double the job, right, then look at the proportion between job and time. If you double the job, it should take you more time. If you double the job, it should take you more people. Correct? So if you look at it logically as well, you should get to an answer. If you want to look at it mathematically, make a separate column for work. Right? In the first case, the work is considered to be 1. Second case, you take the work as 2. Right? No problem. Okay, so it's a toss up between C and E, and this is why I said, right, work rate questions become a little problematic, and you have to ensure that you come to this topic only when you have a good stronghold of how to work with word problems, how to work with ratios and percentages, right? Why? Because how you process information becomes very, very crucial, and it also requires a lot of reasoning, a lot of logical understanding of comparisons between quantities. So I see it's an even split approximately. Some people, more people have given me 8. I've got an answer of 4 as well. So let's see. I'm going to read the question and break it down first. A certain number of masons can complete a job in 30 days. If there were 6 more masons, the work could have been completed in 12 days. Immediately, I know it's a group work question. It's better for me to set it up as a proportion. So, masons and days. X masons take 30 days to finish a piece of work. If there were 6 more masons, so X plus 6, the work could have been completed in 12 days. So, what is happening? The number of masons are increasing, the number of days are decreasing. So masons and days are inversely proportional. I'm going to multiply in a straight line. I can solve for x. So 30 times x is equal to 12 times x plus 6. For people who write the equation directly, please do what you were doing so far. Okay, I saw in the first question people wrote equations directly. If you understand the topic very well that way, do it. I would also do the same. I'm putting the proportions for the benefit of everyone else. Now I would simplify. 6 5s are 6 2s are 5x is equal to 2x plus 12. 3x is equal to 12. So x is equal to 4. So I know 4 masons take 30 days to finish a piece of work, or 10 masons will take 12 days to finish a piece of work. The question is asking me, how many masons would be required to complete a job twice as large in 15 days? Now I can work with it in one of two ways. The first way I prefer, it's more of a logical, common sense way of working. I know from what I found out that 4 masons take 30 days to finish a piece of work. The questions ask me how many masons would be required to complete a job twice as large in 15 days. So it's about a job twice as large. So I will just forget that for now. I don't want to worry about the, twice the twice the job at this point. What if I want the work to be completed in 15 days? How many masons would I require? Imagine the job was exactly the same. So 4 masons take 30 days to finish a piece of work. If I want to reduce 30 days to 15 days, obviously I'll have to increase the number of masons. If you're good with math, you can directly tell me that x is equal to 8. If you're not, follow the proportions, multiply in a straight line. So 15x is equal to 4 times 30. So x would be 8. Now this is not your answer. Remember, I would require 8 masons to finish the same work in 15 days. But if I have to finish twice that work, then obviously I'll need double the number of masons, right? Because I know masons and more work means more masons, right? So if I had the same work and I wanted to decrease the days to 15, I needed 8 masons. But if I want to decrease the days to 15, but I want to do twice the work, then obviously I'll need twice the number of masons. So my answer will be 8 times 2 for twice the work. So 16. This is one way to work with it, right? If you all did not get this, if it was not very intuitive for you, then you can, in the second phase of your working, set it up as 3 quantities. No problem. If you're more mathematically inclined, set it up this way. masons, 4 masons, days, 30 days to finish one full piece of work. How many masons? 15 days to finish twice that work. So it's three quantities that I'm comparing. So I'm going to first compare masons and work. To finish one full work, I need 4 masons. If I need to increase the work, then obviously I will need more number of masons, right? So it's cross multiplication. So x is equal to 4 times 2. I'll just directly write that. That is 8, right? 8 divided by 1 is what I would get. And second, I'm going to compare days and work. I'm going to compare masons and days. 4 masons take 30 days to finish a piece of work. To finish the piece of work in 15 days, I need more masons. So this would be multiplication in a straight line. So 15x is equal to 30 times 4. So x would be 30 times 4 divided by 15. Right? Now I'm going to club everything on the numerator, club everything on the denominator. So 8. Let's write this down so that you understand how I got the 8. So 4 masons, one piece of work, x masons twice. It's a direct proportion, so I'm going to cross multiply. So 1 times x is equal to 2 times 4. So what you get is 2 times 4 divided by 1. Okay, I've written the proportions for the first two quantities. I've written it for the second two. I'm going to club everything on the numerator. I'm going to club everything on my denominator. And masons is the quantity that I've considered twice. Right, masons is the quantity I've considered twice. I've considered this 4 twice, so I'm going to remove that excess. And what I'm left out with is the proportions of everything taken care of. It's a slightly longer process. That's why I said once you get the hang of proportions, you will be able to cut down those mathematical calculation. That would be 16. Right? If 4 machines take 30 days, so for twice job 4 masons will take 60 days. Yes, you can do it that way as well. If you want to compare it with masons and days, that's totally fine as well. I compare it with work, right? If you double the work, then you need double the masons. Up to you, right? Whatever you compare is absolutely fine, right? So for people who did not get that first bit, once I got to the 4, right? Once I got to the 4, it was very easy for me. 4 masons, 30 days. So I assumed, okay, what if the work was unchanged? So if I wanted to finish the work in 15 days, I would require 8 masons. But since the work is doubled, right? Since the work is doubled, I'll need double the number of masons. So that's why my answer is 16. Yeah, you can use the formula men, days, hours, efficiency divided by work. That's a cat formula. It's a formula way of working. M1 D1 H1 E1 by W1 is equal to M2 D2 H2 E2 by W2. But that only constrains your working to men, days, hours, efficiency, and work. What if I give you grams per hour? What if I give you speed? Right? Then you'll have to break it down to its bare bones of finding the proportions, right? So I understand there exists a formula. Like I said, formulae are always limited, right? Even with Venn diagrams, the topic, most of you would have learned the Venn diagrams topic using 3 sets of formulae, but on the GMAT, you will see that the formulae help you at a certain point, but beyond, you'll have to still boil it down to its bare bones. Okay, so somebody mentioned the formula. Um, that formula only takes care of men, days, hours, efficiency, and work. Okay, you'll see a question where I bring in grams per head, and that's it becomes a problem. It is universally applicable only if you have those 5 quantities being given in a question. Correct? Okay, let's try one more. Give it a shot. So when we come to next few questions, Tushit, I would want you to try to use that formula and see where it gets you. Okay, let's see. Shweta, the two quantities that you compare, one will always be the unknown and the other quantity will be the remaining, right? One of the remaining, right? You always keep the unknown as a reference and compare that unknown with one other quantity. Got it? So if you have three quantities, one would always be the unknown, right? Compare that unknown with the first quantity, compare the unknown with the second quantity, right? And then club everything together. Since you've considered the unknown twice, you remove the quantity of the unknown which is extra. Got it? I mentioned it in the notes. You select two quantities such that one is always the unknown. So guys, for people who can't work with this intuitively, finding it hard to figure out what does half as efficient mean, you can make a separate column for efficiency, and this becomes a four quantity. Somebody was telling me, can you take an example where you have four? You don't need the fourth quantity if you understand efficiency well and how it relates to the other quantities. But if you want and you're not able to intuitively work with how efficiency works with the others, make a separate column for it. Right? Okay, you can start typing your answers in the chat window. Remember, guys, the new team is half as efficient, right? So you have to consider the efficiency as well. You don't need to make a separate column if you understand that if they're half as efficient, they'll take double the time, right? Yes, if you're putting everything together, you will remove the quantity twice row, and I will show it to you both ways. Again, I would prefer that you use the first way of understanding what efficiency is, right? And in comparison to the others, right? Whenever you have something like this, right, half of the work or half of the efficiency, solve the question like it is the same work. Solve the question like it is the same efficiency. But if it's double the work, then obviously you need double the number of people. If it is half the efficiency, if every person is working as half as efficient, right, then obviously the time would get doubled, right? So you can look at it like that. That's the best way to work with. But if you can't, if you're not able to work with it intuitively, set it up. Make a separate column for efficiency. You can put one and you can put half, or you can put two and one also, up to you. Try to avoid using fractions. Put 100% and 200% also works. No problem. Okay. Okay, so let's work with it. Men, minutes, articles, right? How long, right? I'll be very careful if for maybe structure, for people who are struggling to which two quantities you take. I see a question there. Just for maybe putting things in a more structured manner, try to keep the quantity that you need to solve for towards the end, please. Okay, it becomes easier then for you to compare. So I'll say men, articles, and minutes. Also, what I want you to understand through my sessions as well, how I organize my information on the worksheet, right? Organization of information is a very important skill set as well, even on the DI section. So 10 men, 100 articles, 30 minutes. How long will it take 40 men to wrap 200 articles? if the new team is half as efficient. So what I'll do when I have a quantity like that, I have a choice. I can either make another column efficiency, I'll solve it in that way as well. Or I can say, okay, let's park that half as efficient as now. What if the efficiency was exactly the same as a constant? Then how many minutes they would take, right? So I have three quantities. I'm going to select two quantities such that one is always the unknown. So men, minutes, 10 men take 30 minutes. 40 men, the number of men is increasing. So the time should reduce. Men and minutes are inversely proportional. So I'm going to multiply in a straight line. So 10 times 30, I'm just going to write that for people who can't write it directly, is equal to 40 times x. So x will be 10 times 30 divided by 40. See, I'm just writing that. I'm not worried about the x at this point. I'm just writing the proportion down. The proportion basically means which of those quantities I'm comparing are going to be on the numerator and which of the quantities are going to be on the denominator, right? Second, I'm going to compare articles and minutes. To wrap 100 articles, it would take 30 minutes. To wrap 200 articles, I'm increasing the number of articles, then obviously the number of minutes would also increase. So I have a direct proportion between articles and minutes. I'll need to cross multiply. So 100x is equal to 200 times 30. So x will be 200 times 30 divided by 100. I'm going to club everything on the numerator, club everything on the denominator. The minutes is the quantity that I've considered twice. This 30. That's why I see two 30s on the numerator. I need to remove that excess. So 10 times 30 times 200. I'm just removing the extra 30 divided by 40 times 100. Right? So this would go. 10 fours, 2 twos, 2 15s. This would give me 15 minutes. But remember, this is 15 minutes when these 40 men are working exactly as the same efficiency as the previous 10 men. Correct? But now they are saying the new team is half as efficient. If they were equally efficient, they would have taken 15 minutes. But since they are half as efficient, if a person is half as efficient, right, then obviously the time would double. Correct? If you're working at 100% efficiency, you finish the work in 2 days. But if you're doing the same work, you cut it down to 50% efficiency, the time will double to 4 days. Same logic. Since they are half as efficient, 15 minutes is when they are equally efficient. If they're half as efficient, then the time would double, right? Since they are half efficient, it would be 15 times 2, which is 30 minutes. So here as well, as someone mentioned, if you feel like using the formula, guys, this is a rote learning formula. It's called M1 D1 H1 E1 by W1 is equal to M2 D2 H2 E2. But I don't like to work with math this way because it limits your thinking only to those quantities. As the next question that we get, the quantities will differ slightly, so it becomes a little difficult to put it in this format. But absolutely fine, right? Normally, the quantities that you're dealing with, the formula is a relatively useful one because you're dealing with men, days, hours, and efficiency and work, the normal quantities that you get in a time and work question. So, for people who want to use this formula as a rote learn formula, you can use it. But trust me, on the higher levels, your understanding of proportions will be more useful to you. Okay. Now, for those who wanted me to put 4 quantities and work with, you can still do the same. I'll show it to you. I prefer to look at efficiency, half as efficient, solve it for full efficiency, and then double the time. If you are not comfortable doing that, then I would say efficiency is 2, and I would keep this efficiency as 1. You can keep it as 1.5. I just want to get rid of the fraction. So now men and efficiency, right? So I'm going to take men, minutes, men and minutes, 10 men, 30 minutes, 40 men. I'm increasing the time, increasing the men. So that's to reduce. That would be 10 times 30 divided by 40. Then I'm comparing articles and minutes. More the articles, more the minutes. So it would be cross multiplication. 200 times 30 divided by 100. And finally, I want to compare minutes and efficiency, right? So if I work at double the efficiency, I finish it in 30 minutes. If I reduce the efficiency to one, obviously the minutes will increase, right? So efficiency and time are inversely proportional. So I multiply in a straight line. So 30 times 2 divided by 1. Now, since I've considered this quantity minutes 3 times, I will remove one of the 30s on the numerator. So 10 into 30 into 200. I'm going to remove the other 30 and the other 30 into 2 divided by 40 times 100, right? So see, I have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. I think I need to put 10 times 30, 200 into 30 into 2. So 10 times 30 into 200 into 2, 440 into 100 into 1. I'm going to simplify that. That's 2. 10 fours, right? 2 goes here. That will give me 30 minutes, right? You can make it how many ever you want, but it's not the most efficient in terms of working. But if you're not able to do it intuitively, guys, this is what you do. Make a separate column, no problem. If you understood the process, it'll just take you maybe 30 seconds for 40 seconds extra, but it works, right? But what I did is when I saw half is efficient, I parked it at the side. I said, what if they are equally efficient? I found out that time half is efficient and double the time. You can take any order, doesn't matter, right? It will not matter. You can take any order. You want to start with articles and minutes, start. You want to take men and minutes after that, do it. You will get the same proportions, guys, right? Whichever order you take, one has to always be the unknown. Okay, you're comparing this unknown with these three quantities. You're setting it up. So you'll have the same quantity, whichever order you take, you'll have the same quantities on the numerator and the denominator. When you're clubbing things together, remove the extra. That's all. Okay. Yes, you can also say half as efficient means you can work with it with respect to men as well, like somebody mentioned. If they tell me half as efficient, then the 40 men becomes 20 men, right? Because if there are 10 men who are working at 100% efficiency, but there are 40 men who are working at 50% efficiency, that will be equivalent to having 20 men working at 100% efficiency. So you could have done it directly with 20 as well, for somebody who asked me that. Guys, whatever you do, right? If you're doing half as efficient, you can compare efficiency to men and work. You can compare efficiency to time and work. Doesn't matter. What matters is how is the relationship between efficiency and men, how is the relationship between efficiency and minutes. That's all. Correct? Okay. Let's pump it up a little further. All right. Give it a shot, please. Yes, Shiv, what you said is right. If it is half or if it is 4 times, if it's double, it becomes more intuitive. If it is three-fourth, then it becomes more of a problem, no? So, like I said, right, if you're getting confused and you're not able to do it in your head, you want to write it down, make that separate column and work. Okay. See, my job, guys, is to put in a process that works for everyone. Okay. So I am doing that. How I teach may not be always how I solve. Okay. But the principles remain the same. So, Tushit, this is the question. Maybe you want to try using the formula and see where it takes you. Hmm? You can start typing your answers in the chat window if you're done. It's a tough one, so don't worry if you're not getting it. Tougher questions will always have some amount of reasoning, some amount of visualization that you'll have to consider. Yes, Ansh. So that's an equation process. So the same equation I would get in the comparisons, right? So the same kind of working you would see if I compare it with proportions as well, right? So Tushit, what about the formula? Where would you put the ounces per head? Yes, Sarah, that's also right. Okay, so I see a few answers. It's a tough question. It's actually a tough question because it requires a little bit of visualization. It also requires a smart way of setting things up. Normally, what test takers do in such questions, right? They get so, um, you know, um, sidelined by the numbers that are given that they don't read and visualize the question. Okay, the best thing to do in word problems, that's why I said, right, always attack this topic or work this topic only when you have a good handle of how to break down and work with word problems, right? Read the question carefully, visualize it like a real life scenario. Imagine that you are the person who's in charge of rationing in that garrison. Okay, a garrison, basically, for those who don't know, it is a group of soldiers, right? So a garrison of 3,300 men had provisions for 32 days when given at the rate of 850 ounces per head. So immediately I see, okay, 3,300 men, 32 days of food, 850 ounces per head. So I know I'm the person who's in charge of rationing. I have 3,300 soldiers in the camp. If I give each soldier 850 ounces, the food that I have will last for 32 days, right? So I'll write that down first. Men, you can put men to the right hand extreme because that's the question, but I mean, I'm just going to do it normally. You have days, 32 days, and you have grams per head. That is 850 ounces per head. I'm just putting grams per head so that we use grams. So I'm just making it as real life in nature as possible. But as soon as I read the next line, right? Remember, I am in charge. I want you all to visualize that you are the person in charge of rationing. At the end of 7 days. So, what is the meaning of that? At the end of 7 days, that means for 7 days, these 3,300 men have eaten food. So, at the end of 7 days, if I take stock of the food that I have, I still have 3,300 men at the beginning of at the end of 7 days. But instead of having 32 days of food, I have only 25 days of food. So this is what you have to understand. I can't do the calculation directly with 32 because they're telling me in the next line at the end of 7 days. So for 7 days, those 3,300 men have eaten food, right? So I basically have 3,300 men, 25 days worth of food when given at the rate of 850 grams per head. But what happens at the end of 7 days? At the end of 7 days, a reinforcement arrives. That means extra people have joined in. And it was found that the provisions will now only last for 17 days. Makes sense, right? Because more people joining in, the number of days would reduce when given at the rate of 825. So what did I do? As soon as people joined in, more soldiers came in, I had to recalibrate. So I said if I reduce the amount that I'm giving per person to 825, I will be able to feed all of these people, but the food will only last for 17 days. But I don't know now what is the total number of people who have come in. You can write that as X. You can also write as 3,300 plus X, where X represents the excess. I'm just going to write X as my total. And once I get to the total number of people, I can subtract it from 3,300. So I've set up my proportions here. The questions ask me what is the strength of the reinforcement. So the strength of the reinforcement would be X minus 3,300. This is what I have to solve for. You see what I'm doing, right? I am engaging with the question. I'm reading it carefully. And more importantly, I'm visualizing the question like a real life scenario. I'm putting myself in that question. I'm looking at it from a first person's perspective. Now, since I have my quantities set up, I can use the proportions concept. So for people who are using the formula, this will not fall under men, days, hours, and efficiency, right? So you'll have to think about the proportions between the quantities step by step. So I'm going to select two quantities at a time such that one is always the unknown. 3,300 men, 25 days. Obviously, the days would reduce if number of men increase. So the proportion between men and days is an inverse proportion. An inverse proportion means I'm multiplying in a straight line. So 17x would be 3,300 times 25. So 3,300 times 25 divided by 17. That's the proportion between men and days. Now I'm going to take men and grams per head. I can feed 3,300 men if I give each person 850 grams per head. But if I reduce the amount that I'm going to give each person, then I can feed more number of men. You see, if I reduce the amount of grams I'm giving each person, I can feed more number of men. Or you can look at it as there are more number of men joining. So if I need to compare it with the food, I need to reduce what I give each person because I have to feed those extra men. So men and grams per head are also inversely proportional. So I'm going to multiply in a straight line. So 825 into X is equal to 3,300 times 850. So that will be 3,300 times 850 divided by 825. I'm going to club everything. Men is the quantity that is unknown that I've considered twice. So 3,300 occurs twice. I'm going to remove that once. So 3,300 times 25. I'm not going to write the next 3,300 into 850 divided by 17 into 825. Right? Now I'm going to simplify. 25 goes into 825, 25. 3s are 75. I'm left with 7. That's another 3. Questions on the GMAT will always be nicely, we'll factor out. This will go into this 100. And 17 times 5 is 85. 70 times tables. If not, you can work with it. Right? 50. That's 5,000. So X is 5,000. I should not pick 5,000 as my answer. The questions ask me what is the strength of the reinforcement. You see, I wrote down what I'm solving for in the beginning. The reinforcement is how many extra people have come in. So that's 5,000 minus 3,300, which is 1,700. That is my answer. A. So you see, guys, I'm just using proportions. For those who wrote the equations directly, you see, I'm getting to exactly the same equations, right? That you've got, right? I've just used the concept of proportions to get there. Got it? Any doubts? And what about the formula here? No, not going to be very useful, no, because I have to still figure out grams per head and the proportions between the quantities. That's why I said, right? Yes, most of the questions you can make use of the formula, provided the quantities are men, days, hours, efficiency, and work. All right. Any doubts? Okay with how I set it up? This would be how a hard question looks, right? You'll have to have that, intuitive ability of understanding that if there's 32 days of food, at the end of 7 days, it would only be 25 days of food. Got it? All right. Okay. A last question before we move into independent work. I want you all to try it, please. It's not too difficult, right? But if you've got the crux of what I've been telling so far, I think you will be able to solve it as well. Try it out, please. Again, the key lies in how you read and how you set the question up. Okay, you can start putting your answers in the chat window. It's not as difficult as a question as the previous one. Okay, only two answers so far. It's not a difficult one, to be very truthful. Okay, for those who are not getting it, can you type in the chat window where you're stuck? Right, so that normally, I told you, my experience, the issues will be based on reading, based on visualizing. You'll miss out on information. You will not know what to compare. So focus on that, please. Focus on reading the question and trying to make inferences from what you read, line by line by line. I don't know why I'm getting 4750. Okay. Others? Okay. C is coming slowly. Okay. Taken units 500 and X with days as 1 and 15. See, this is where I think you should not focus on the numbers, right? And this is something, guys, I want you all to understand this very carefully. And that's why word problems, time and work becomes very, very, very difficult because you don't read the questions carefully and don't understand what you're comparing to what. Don't focus only on the numbers, please. Okay? Don't focus on the numbers. A certain factory normally produces 500 units per hour. That's key. For a 7.5-hour workday. So every workday is 7.5 hours, and every day it produces 500 units per hour. So what is the first thing that I would do? What is the thing that from a common sense standpoint I would work with? If they're telling me it's 500 units per hour for a 7.5-hour workday, so I know that the total number of units produced in one workday should be 500 into 7.5. This is the work that needs to be done in one day. You see what I'm doing? I'm thinking about this logically first. I'm reading the question and I'm working with it. Right? In a month with 22 work days, no units are produced in the first 7 days because of a job action. So there's absolutely no work done in the first 7 days. By how many units must production increase on each of the remaining work days of the month in order to meet normal production levels for the month? Right? So, what is the production level per day? So, the production level per day is going to be 500 into 7.5. Right? This is per day. And this would be the normal units that is produced on each workday. So I know that if I'm taking a month of 22 work days, there is absolutely no work done in the first 7 days. So ideally, the comparison here has to be between the work done per day, right, on each of the days and the number of days. Because they are asking me if I reduce the number of days, remember the first 7 days, there's no work that is being done. And I know it's a 22-day month. If I'm not working for the first 7 days, I know that I'm only working for 15 days. So the question is asking me, by how many units must the production increase on each of the remaining work days? So what is being compared? the units of production that I've produced in each day to the number of days. So you're producing 500 into 7.5 units per day, and you're doing it for 22 days, right? But since you've not worked on the first 7 days, the number of days now would be 15. So obviously, if you're going to try to finish the work in 15 days, you'll have to increase the amount that you produce per day. So if I reduce the time, I have to increase the amount that I've produced per day. This would be the units produced per day, right? So this would be X. So there's a inverse proportion between the two. So 500 into 7.5 into 22 divided by 15. 15 goes to 7.5 0.5 times. 0.5 is half. Half into 22 is 11. That's 500 times 11, which is 5500. And remember, the question's asking me, by how many units must the production increase? So it has to increase from this to this. So 500 into 7.5 is 7.5 times 5. 5 5 is 25. 5 7 35. 3750. So that's 3750 units. I have to increase it to 5,500 units. That would be 5,500 minus 3750, which is 1750. That's my answer. Got it? So the comparison is between what is the normal units produced per day with the total number of days. That's what the question is. By how many units must the production increase on each of the remaining work days? Right? So what is the units per day that I have if I'm working for 22 days? It's 500 into 7.5. But I obviously need to increase the production per day if I need to reduce the time, right? If I need to finish the entire work in 15 days, the amount that I produce per day should be more. So the comparison is a inverse proportion. I'm going to multiply in a straight line. I get 5,500. I should not forget it's asking me how many units must production increase. So it's the difference that I want. So 500 into 7.5 is 3750 units. What I've got is 5500 units. The difference is 1750 units. Right? Got it. Yes, you can do it that way as well. I didn't know how to fit the solution in the procedure we spoke about. The way I saw initially was to find how much we produced in 7 days and that divided by 22. Perfect. Right? So how much you would produce in 7 days would be, right? If you're not working for 7 days, it would be 500 into 7.5 times 7, right? So that is what you're not producing, right? So the difference between what should be produced in 22 days and what you're not producing should be the excess. Absolutely fine. Okay. Any doubts on this? You see, the key lies in harder questions. The key lies in how you read and process the information. Right? If you've done it that way, also absolutely fine. So somebody said that 500 units, 7.5 hours workday for 7 days, found out how many units are going to be done in 7 days, found out what needs to be done in 22 days, found the difference, and then worked with the rate to compare. Okay. All right. So this is what you have to do, right? I'm just giving you, a small snippet. Why? Because this is important to understand the concept of proportions, because it carries forward as well into speed, distance, and time that we will not be doing in today's session. We'll be doing it in a session later, right? Because with speed, distance, and time as well, if you work with proportions, your questions where two bodies move become very, very easy if you look at things in the form of proportions, right? By that, I got the following: 500 into 165 divided by 112.5. Can you tell me how you got 165, Sivadas? I think you've done some working. So think about it logically, right? I mean, I can't work with the time. See, one thing that you have to understand is I can't work with time. The only thing, you learn it later as well as we go forward, the only thing that you can manipulate is the work and the rates. Okay, never manipulate with time. All right. Okay, so that's the first bit that I want to speak about in the time and work, right? The concept of group work. Now, what happens when you have independent work? Again, like I said, when you work with independent work, there's no concepts you have to understand, but everything boils down to the concept of rate is equal to work divided by time, right? Everything boils down to this. When you work with independent work questions, right? When you work with independent work questions, how you structure your information becomes crucial because there'll be multiple moving parts in the question. You'll have to organize your information well. So let's take a simple example, okay? And I want you all to do solve the question in the way you would normally do it. And I'm going to use this question as a blueprint to put in a structured process that I use towards working time and work questions here. So let's say A takes 3 days to finish a piece of work. B takes 6 days to finish the same work. How much time would A and B take to finish the entire work? Okay, I'm starting with a ground zero question. Try it out, please. Do it in the process that you normally use. Okay, and then we'll use this example, ground zero example, as a blueprint to put in a structured process of working. Perfect. So what most of y'all will do on such a question is y'all will keep the work as one unit, right? Most of y'all would use this process as an alternate process as well. You would get to the rates. You would say the rate of A is 1 by 3, right? You will say the rate of B is 1 by 6. And since they're working together, you would add the rates up. You can't add times, remember, right? It wouldn't make sense for me to say if A takes 3 days, B takes 6 days, totally they'll take 9 days. We'll add the rates up, 1 by 3 plus 1 by 6. And we'll take the LCM, which is 6. That's 2 plus 1. That's 3 by 6. This is the rate. And then you'll use the formula. You want the time of A plus B. So the time of A plus B would be the work divided by the rate, right? And this is where you in school they would have told you take the reciprocal. The reason you're taking the reciprocal is because you're taking the work as 1 and the rate is 3 by 6. So you take it on top, that will be 6 by 3, which is 2 days. Now this is the process that most test takers employ, right? I'm just going to make a small tweak to that process, right? You can definitely use this as well if you're comfortable doing that. What I tend to do when I work with a time and work question, I follow a very simple, structured process of working. I'm going to write down that structure on the screen and I'm going to leave it as it is for you to refer to, right? The first step when I'm working with an independent work question, I'm going to read, I'm going to visualize the question and set up the data in a nice structured RTW table. Organization on your worksheet is a crucial aspect in this topic. Try to put things in terms of a rate, time, and work table. Second, so if this was a question that was given to me, I would make a table like this. I would say rates, time, work. I would say A takes 3 days to finish a piece of work. B takes 6 days to do the same work. I'm putting in the data. Any extra data that is given to you, any additional data that they give you, either other than the rate, time, and work, any additional data, make a note of it at the side of your table. There's no additional data in this question. We will work with questions where there's additional data as well. But if there's an additional data, write it to the side of the question. Third, see what you have to understand in a time and work question is it becomes very crucial for you to convert time to rates and work because you can't do any algebraical manipulation using the times. Okay, you can't add times, you can't subtract, you can't multiply, but you can always add rates, you can subtract rates, you can add work, you can subtract work. You can always algebraically manipulate rate and work. You cannot do that with time. So whenever we have a question on rate, time, and work, it becomes imperative that you convert things in terms of rate and work and then set up your algebra based on that. So what do I do? Third step. For me to get to the rate, I have to set something as the work. So if I have a question where the work is not given to me, they have not categorically mentioned what the work is going to be, right? Then, if the work is not given, I can use one of two approaches. I can either take the work to be 1 or x, or I can take the work to be the LCM of the times. The conventional process is to take the work as 1. How I work with it is if I see that my times are variables, if I see that I have the times given to me in the form of variables, I would always prefer to keep the work as 1 or the work as x. But if they give me the times to be definite numbers, all the times that they mention in the question are definite numbers, I can tweak this process a bit. I can take the work as the LCM of the times. I'm being smart with it, right? I don't want to get into calculations with fractions. So what am I doing? I'm free to use anything I want for the work because the work is not categorically mentioned. So if the work is not given and I see that the times given to me are numbers, I would prefer the LCM, taking the LCM of the times. But if the times are variables, I would prefer the work to be 1 to get to the rates. But if the work is categorically given to me, or I'm asked to find the work, right? I will definitely use the data given. I will not introduce any number, neither will I introduce any LCM or keep the work to be X. Okay, so how you set up your question will determine how quickly you can get to an answer, right? You can make it very intuitive in nature if you have the times to be numbers, right? So I'll work with a second first since we worked with already taking the work as 1. So what I would do, I would keep the work as the LCM of the times, which is 6 units. And immediately I would find the rates. So if it takes A 3 days to do 6 units of work, the rate of A would be 2 units per day. And if it takes B 6 days to do 6 units of work, the rate of B would be 1 unit per day. You see, I'm being smart with it. And what is my question asking me? It's asking me the time that A plus B take to finish the entire work. So once I set up my work and get to the rates, so the fourth step is obviously get to the rates. You should always look at rates as algebraic equations. Always remember, treat rates as algebraic equations. It's like this. How I would visualize this is A is 2, B is 1. Always rates should be looked at as algebraic equations. So if A is 2 and B is 1, A plus B would be 3 units per day. And the questions ask me how much time would it take A plus B to finish the same work of 6 units. So 3 units per day, 6 units, A plus B would take 2 days. That is my answer. So yeah, just use my table, organize my information, cut out the usage of fractions by just making one small tweak. Whenever I have the times to be numbers, I can quickly put the work, instead of taking the work to be one, take the work to be the LCM. This will be a very beneficial process, especially when you get harder questions where objects or people are moving in and out of a question. They tell you A and B work together for 2 days, then B leaves and goes, C joins in, then A and C work together for 3 days, A leaves and goes, B comes back. So when you have a question like that, going with fractions is going to be a slightly more tedious process. But if you can tweak that work, and instead of taking one, take the work as the LCM of the times, the question becomes a lot more intuitive to work with because you're working with whole number values. Correct? So I'll always get to the rates. And once I get to the rates, I will treat the rates as algebraic equations. And once I treat the rates as algebraic equations, I will set up my equations and I would solve. So how would I set up my equations? I would always set up my equations either using the rate or using the work. When would I choose rates? Whenever objects are finishing the work, working together, I would always set up my algebra using the rates. But in more difficult questions, people will move in and out of a question. So when I have objects moving in and out of a question, I would always set up the algebra using the work. Remember, rates and work should always be the two quantities that you use to set up your algebra. Okay? Ideally, you try to use it with rates, but when you have a question where multiple people are joining and leaving, it's always better for you to set things up using the work and break the question down. All right. So let's try one more question. Right, just giving you a practice, maybe a level 1 question before I go into actual GMAT questions. Let's say I'm just creating a question again on top of my head. A and B working together takes 6 days to finish a piece of work. B and C working together take 9 days to finish the same work. A and C working together take 12 days to finish the same work. So my question again, what is the time that A alone takes to finish the entire work? Or they could have also asked you, what is the time that all three of them take to finish the entire work? Remember, try to use the structure that I've set up on the right hand side. Right? Set up your information first. Read, visualize the information that is given. Set up your data in an RTW table. Set up the work, set up the rates, get your table done, and then decide what the question's asking and see how you're going to manipulate the information that you have. Okay? Then we'll go into actual GMAT questions. Yes, Kuhan, I think I saw your LinkedIn request, right? So you can ping me on LinkedIn. I think it takes me some time to respond, okay, because I have a lot of things on my plate. So, but you can just ping me whatever your query is on LinkedIn. I'll be okay to respond to that. The answer, obviously, I'm just creating a question in my head, so it may be a fraction. You can give me whatever fraction you got as your answer, no problem. Okay, you can start typing your answer in the chat window. Those are finished. We'll build from here. Okay, you'll see I'll make the questions more and more complex, but I'm going to adhere to those structures that I've put in. Okay. All right. So let's put it in. Guys, can you hear me? I think someone's messaged that they're not able to hear me. Okay. Yes. All right. Okay. So let's work with it. So again, I'm gonna put it in terms of my table, right? I'm going to visualize the question. I have two people working, finish the work in 6 days, another two for 9 days, another two in 12 days, and I want the time that A alone takes to finish the entire work. Again, I'm not going into tougher zones, right? This is again level 0 or level 1. First step, set up your data, organize it in an RTW table. So I have A plus B will take 6 days to finish a piece of work. B plus C takes 9 days. Take 9 days to finish the same work. And A plus C take 12 days to finish the entire work. There's no additional data here. The work is not given as well. So I'm free to either take the work as one or take the work as the LCM of the times. I would prefer the LCM because it gives me whole number values to work. I have the work here as the LCM of 6, 9, and 12, which is 36 units. So if A plus B do 36 units in 6 days together, they would do 6 units of work per day. B plus C, 9 days, 36 units. So if 9 days, 36 units of work is done in one day, it would be 4 units per day. And again, 36 units, 12 days would be 3 units per day. Now, like I said, as soon as you finish your table, treat the rates as algebraic equations. So I have A plus B is equal to 6. I have B plus C is equal to 4. I have A plus C is equal to 3. And the question's asking me to solve for A alone. So now I need to look at these three equations and I need to manipulate these equations in such a way that I solve for A, correct? So if I need to solve for A, I need to try to get rid of B and C, or I can add everything up. I'll get 2A plus 2B plus 2C, and I can remove B plus C out of it, right? Or I need to get rid of B and C. If I have to get rid of B and C, I can subtract my first two equations. So A plus B minus B plus C would give me A minus C is equal to 2. And then I can add it to the third equation, which gets rid of C for me. That will give me 2A is equal to 5. So I have A to be 5 by 2, which is 5 by 2 units per day. And I need to do 36 units of work. So that will be 36 divided by 5 by 2, which is 36 divided by 5 by 2. So that's 72 by 5 days. That would be my answer. I'll just write it down better here. Right? So this is 36 units. Remember, I'm solving it. So I subtracted the first two. So A minus C was 2. I added it to the third because I'm solving for A. I need to get rid of B and C. So 2A is equal to 5. So A is 5 by 2. What is this A is equal to 5 by 2? It is the rate. It is the rate of A because we are treating the rates as algebraic equations and manipulating them. So if the rate of A is 5 by 2 units per day, you need to do 36 units of work. The time of A would be the work done divided by the rate of A. Okay, that's the formula I'm using. Right? So the work done is 36 divided by 5 by 2. So that's 36 into 2 by 5, which is 72 by 5 days. That is my answer. Got it? So you see, I'm using this process. It's a more intuitive process of working, of using the work as the LCM rather than keeping the work to be one. And you'll realize the usefulness of this process, especially when you have questions where people are moving in and out of a question. All right. Again, I'm going to leave that structure on the right hand side, and I want you to compare what I did here. Any doubts on this? I'm just trying to organize the information for you. And what is important as well, that's why I said, again, I would do this topic towards the end of my preparation of word problems and algebra, because what you end up here is algebraic equations that you will have to manipulate to get to what the question is asking you to solve. The question was asking me to solve for A, right? So if it's asking you to solve for A, I want to get rid of B and C. What you could have also done, if you wanted, what you could have also done in terms of manipulations, you could have added everything up. So you would have got 2A plus 2B plus 2C is equal to 13. And then you would have got A plus B plus C is equal to 13 by 2. I already know what is B plus C. B plus C is 4. So A will be 13 by 2 minus 4. That will be 13 minus 8, which is 5. A will be 5 by 2. That's also possible for you to manipulate. I leave it to you how to manipulate the equations. The equation should be manipulated based on what the question is asking you to solve. Got it? But what did I do? I made a small tweak that whenever I have the times to be numbers, I have the option to use the work as the LCM of the times. Got it? Any doubts here? No? Okay, let's get into a question. I'm going to leave those structures for you all to refer to. Right? Let's move on to okay. Give it a shot, please. Question 8. Start with a simple one first. Remember, when you take the work, when you have the times as numbers, you can work with the work to be the LCM of the times that you have. If you have the work to be, if you have the time to be variables, stick to the process of one. Okay, keep the work as one, set it up. But organize your information in the form of an RTW table and understand that the algebraical manipulations always have to happen via the rate or via the work. Don't get into calculations from the outset, guys, right? Focus first on putting in the information in that table, right? Putting in as much information as you can in that table. then deciding whether you want to manipulate things based on the rate or based on the work. Okay. If the times are given to you as numbers, make that tweak, keep the work to be the LCM. If not, stick to one. You can start typing your answers in the chat window. Okay. So again, I want you to notice how I organize the information. I will always first figure out the pieces of my puzzle before I go into putting those pieces together. All right. And I'm going to adhere to the structure. I'm going to read, I'm going to visualize, and I'm going to set up my information in that table first. Working alone, a small pump takes twice as long as a large pump takes to fill an empty tank. So I have rate, time, work. A small pump takes twice as long as a large pump takes to fill an empty tank. So let's say a small pump takes what, X hours. The large pump takes X hours. The small pump will take 2x hours. You see, I'm reducing my variables as well. I'm using translation to my advantage. I'm setting things up. I'm reading my first line, trying to put as much information I can in that table. Working together at their respective constant rates, the pumps can fill the tank in 6 hours. So I will write S plus L. It would take 6 hours to fill the entire tank. How many hours would it take for the small pump to fill the tank working alone? So I need to solve for 2x. You see what I'm doing? I'm not getting into calculating from the outset. I'm trying to first figure out what data does the question provide. I'm trying to put in as much information in my table, and then I'm going to focus on the table and trying to get to the rates, right? So I have 2x, x, and 6. I have the times to be variables. I can stick to the work as 1. I will find the rates. That's 1 by 2x. I have the work as 1 here. That's 1 by x. And I have the work as 1. That will be 1 by 6. And I told you rates have to be considered as algebraic equations. So it's like s is equal to 1 by 2x, L is equal to 1 by x, and s plus L is equal to 1 by 6. Right? So I have 1 by 2x plus 1 by x is equal to 1 by 6. 2x would be my LCM. That's 1 plus 2 is equal to 1 by 6. 3 by 2x is equal to 1 by 6. 2x is equal to 18. X is equal to 9. But remember, the question's asking me for 2x. So 2x has to be 18. That is my answer. Right? You see what I'm doing? Again, I'm organizing my information. Right? You can take the work as the LCM as well if you're good with variables, but you're free to do what you want, right? You want to take one. I normally take one for times to be variables. I take the LCM to work with numbers because it becomes more intuitive. But at the end of the day, my algebraical working is always going to be either via the rate or via the work. Here, I can't use the work to set up my algebra. So it's always going to be via the rate. So 1 by 2x plus 1 by x is equal to 1 by 6. So remember, rates have to be always looked at as algebraic equations. Got it? Any doubts here? I started just a level 1 question on the GMAT. Okay. But you see, I'm using the same principles of what I set up. I read my question, I visualized, I put in the information, I read the entire question, put in as much information I can. Then I worked with my table to get to the rates by setting up the work because the work was not given. Then I read the question, I saw what I need to solve for. I created my algebraic equations via the rates. All right. Any doubts? Easy one again to start with, just for you to get the hang of things. You'll see I'm always going to respect this process going forward. All right, let's make it a little harder. Let's try question 9. Again, what I want you all to do is focus first on reading the question, visualizing it, organizing your information in that table. Don't get into solving at the first stage. Organize the information, set up the work if it's not given, get to the rates, then take stock of the information based on what the question's asking. Learn to translate the information that you have nicely into a set of data in the form of a table. Give it a shot. 2 minutes. Okay, you can start typing your answers in the chat window, please. Okay. Again, following the same structures, what is the first step? Read, visualize, organize your information in an RTW table. Figure out the pieces first. Don't get into calculations. A company has two types of machines, type R and type S. Operating at a constant rate, a machine of type R does a certain job in 36 hours, and a machine of type S does the same job in 18 hours. Okay, I have R takes 36 hours to finish that same work. S takes 18 hours. And remember, this is one machine R and one machine S. If the company used the same number of each type of machine to do the job in 2 hours, so they're taking 2 hours, but they're using the same number of machine R's and the same number of machine S. I don't know what number it is, so I'm going to say X times R plus X times S using the same number of R machines and the same number of S machines to finish that same job in 2 hours. And the questions ask me how many machine R were used. It's asking me to solve for X. You see what I've done? I've read the question, I have processed every piece of information step by step. I've set it into a table. I've tagged things in the right way so that I'm clear about what data I have. My next step is to figure out the work, get to the rates. Since the times are all given to me in terms of numbers here, I can choose the work to be the LCM of the times, which will clearly be 36 units. So this would be 1 unit per hour. This is 36 units. 18 hours for 36 units means it would take 2 units per hour, the rate. And it's 36 units, 2 hours to produce 36 units. That would be 18 units per hour. Now look at the rates as algebraic equations. I have R is equal to 1. I have S is equal to 2. And I have XR plus XS, which is 18, which can be written as X into R plus S is 18. You see, rates are always algebraic equations. So if R is equal to 1 and S is equal to 2, 1 plus 2 gives me 3. So I can say 3x is equal to 18. X would be 6. Done. Again, I just bumped the level of the question slightly a notch. Still not gone into very difficult zones. But you see, I'm adhering to the structures, right? What have I done? I followed the structures. I've read, I've visualized, I've organized my information, figured out my pieces available first, figured out the work, got to my rates, then decided what needed to be done in terms of algebra. I set up my algebra. Again, I worked with the rates here. Rates should be considered as algebraic equations. And I got to what the question's asking me. Got it? Any doubts on this? Again, right? I'm going to endorse this process of working, and you'll see, however difficult the question gets, I'm not going to deviate from the process, right? More difficult questions obviously would have people moving in and out of a question. You would have more pieces of information given to you. So I will go into those kinds of questions later. But for those who didn't get this, did you understand how I organized the information, how I used that structure to set things up, how I was flexible to use the work as the LCM whenever the times were given to me as numbers? It makes things more easier to visualize for you. All right. Any doubts on this? Please ask me here, because as we are going forward, the questions are going to become more and more difficult. Okay. And I'm going to take in data sufficiency questions as well based on this topic. It's a very important part of the time and work topic. Right. Any doubts? Okay. Why stick to this process is because most efficient. We'll see. If you feel you want to use the work as one and work, absolutely fine. Let's see what happens when you have more difficult questions where people are moving in and out of a question. Okay. Again, we'll increase the difficulty level slowly as we move forward. You can take the work as one as well, Aditi. In your case, you will have fractions. If you take the work as one, you'll have 1 by 36, you'll have 1 by 18, you'll have 1 by 2. You will end up getting the same algebra, but with fractions. The only tweak I'm making, it's not a different process, Aditi. Okay, Samir and Aditi, it's not a different process that I'm giving you. I'm using the same process that you use. It's just that I'm being smart by taking the work to be the LCM of the times when I have the opportunity to do so. Why? Because it gets rid of fraction working for me. Got it? If you want me to do it with the work as one, I don't mind doing it as well. Or did you understand? It's the same process. You're keeping the work as one and working. I'm keeping the work as the LCM of the times because I have the opportunity with the times being numbers. Okay. Okay. Give it a shot, please. Whenever the times are numbers, guys, feel free to take the work as the LCM if it's not given. If the times are variables, stick to one, right? If the times are if the work is categorically mentioned, use the data that is given to you. not too difficult again. Ensure you organize your information well. For people again who are asking, why should I use that process? I can use the work as one. As we go forward, you'll understand when objects are moving in and out of a question, it becomes a more intuitive way of working. Okay. Do what you're comfortable with. If you're comfortable using the work as one, please continue that. But like I said, some questions, if the working becomes too overwhelming, make that tweak, especially when you have the times as numbers. You can start typing your answers in the chat window. Yes, I will have a break of 5 minutes. Okay. Okay. So we are halfway through. I think I had around 20 questions and so on. So the harder questions are coming up in the second half. So we will take a break after the discussion. So I see most of you all have given me an answer. Again, for those of you all who are struggling to organize the information, focus on that first. Machine M, working alone at its constant rate, processes 1 ton of a chemical product in three-fourths of the time that machine N, working alone at its constant rate, does. So translate this. They've given me the work specifically as 1 ton. So rate, time, work. Machine M, 1 ton of work, right? Processes 1 ton in three-fourths of the time that machine N, working alone at its constant rate, does. So if I take three-fourths of the time, let's say this is 4x, I'll keep that as 3x, three-fourths of the time, right? So the work is 1, so this will be 1 by 3x, 1 by 4x, right? And the question says, if the two machines working simultaneously at the respective constant rates process 1 ton of the chemical product in 6 hours. So they're working together. It processes 1 ton in 6 hours. So I have the times given to me. I'm using the work as what is given because they've categorically mentioned what the work is. I'm sticking to that. I've kept the time of n as 4x. The time of m is three-fourths of that time, so 3x. And then together they're doing it in 6 hours. How many hours will it take machine n working alone to process this amount? So I need a value for 4x. I'm going to finish my table. So my rate's going to be 1 by 6. I'm going to manipulate the rates. I'm going to look at it as algebraic equations. So 1 by 3x plus 1 by 4x is equal to 1 by 6. Right? So that's 12x. That's 4 plus 3. That's 7 by 12x is equal to 1 by 6. 6 ones are 6 twos are. So 2x is equal to 7. X is equal to 3.5. Right? I need 4x. 4 into 3.5 will give me 14. That's your answer. Right? Got it? You could have also, if you wanted, taken the LCM of 3x, 4x, and 6, put it in work, and you would have just avoided the usage of these fractions in your working. Right? But like I said, I always use it only for numbers. If it is variables, I prefer to use one and work with it. So it's not a different process. I'm just tweaking that process. I'm saying try to use the information to your advantage. Okay. Of course, you can take n as 3, n as x, and m as 3/4 of x. That's also fine. I'm just using a smart way of working, right? If someone tells me 3/4, I would want to keep 4x and 3x because it avoids the usage of fractions. Okay, it doesn't change anything, guys. Okay, the very fact that I'm taking 4x and 3x, it's still 3/4. No, so you can take x and 3/4 of x and work with it as well. It doesn't change your answer. But this is something, again, I want you to observe that I try to avoid using fractions wherever possible because fractions is very messy. A lot of ugly calculations, especially when a question becomes more complex. to keep track of the fractions that you have is going to be slightly more difficult. That is why that's another reason why I'm endorsing the process of using the work as the LCM, because it gets rid of that fractions. Okay, so we'll take a 5-minute break. We'll reconvene at 11:40. I'm going to be still online, so you can, in that maybe 5 minutes, for those who are with me, you can ask me certain questions. Okay. Doing the equation and calculation without pen and paper helps visualize the process better. Um, if you're learning it for the first time, Tammy, I would recommend putting pen to paper, because the more you put pen to paper, the better you will be able to process things in your head. Otherwise, it becomes very a lot of clutter. So to declutter, put pen to paper in the beginning, and but as you go forward, and as you get accustomed to the process, doing things in your head becomes a lot more easier. Yes, there's. I told you, there's no theory that is required for time and work, other than the work that rate is equal to work by time and maybe group work, right? Everything deals with how you structure your information and how you work. So I'm putting that structure, and I'm going to now take it into harder zones, and I'm going to adopt the structure even on data sufficiency questions. So I'm going to, maybe add on what you need to do for a data sufficiency, and we would work with questions. The second half, right, would deal with slightly harder questions. So you can, if it's too late for you, you can log off and you can have a look at the videos. No problem. I will also upload the PDF of the questions as well, along with explanations in the in the comment section, so you can have a look at it later. Somebody also asked me, so you're doing rates now, so when will we do word problems and ratios? Guys, I have 8 sessions that I need to do with GMAT Club. I've tried to keep the sessions more tailored towards difficult topics that normally test takers struggle at, right? It would be very difficult for me to teach word problems then go to ratios, percentages, because then we'll have to have like sessions every 2-3 weeks, right? And that would be a long duration. So it's 8 sessions, and I've tried to choose the topics based on your recommendations as well, to be topics that people normally would need help on. Yes, the video is going to be available on the channel, right? You'll also have the PDF attached with it as well. Could you show how to solve problems of factory units by using total hours approach, 7 days? What I'll do, Sivadas, I will put it as an explanation, as a solution to in my PDF for you specifically. Okay, I will write in 2 processes of working. Okay, I normally in my PDF cater to multiple solutions. I will add it as one of your solutions. All right. Are we going to have any sessions on ratios? Guys, I think you have a good set of videos also from GMAT Ninja, right? On ratios, on fundamentals of word problems, and so on. Make use of it. I think it's a good source as well, right? So the intention behind the sessions was to, one, put in some content, especially for people who cannot afford taking up a costly program or taking up personal tutoring, right? Who have problems with specific topics, they can go to GMAT Club and then utilize those videos to their advantage, right? So the purpose of the sessions were that it wasn't to cover everything that we have, right? If it has to cover everything, I normally in a personal tutoring setup take 25 sessions. If it's on GMAT Club, 25 sessions in a session once every month would take us 25 months to cover. I can't take it on a very frequent basis as well, right? Of course, please do that, Ansh. Okay, you can put in your doubt, and I don't mind responding. It would be easier for me to respond over an email, so I think you'll have my email ID as well. So put in your doubt over an email. I'll just I have an iPad, so I can craft an explanation. I can send it to you very quickly. Okay. Mixtures, I think there is an old video of mine. I don't know whether it's from GMAT Club, but I think there should be some old video of mine where I deal with the allegations and mixtures process. So maybe you can scrounge and find that out. I think it should be, a video that I'd put in my Crackverbal days, right? So it should be on the Crackverbal channel. Search for that. I think you'll be benefited using that video, right? um, Absolute values as well. I think there is an old video there. So consensus was there's already a video that is there on GMAT Club. So why don't you put something that is new? That is why I chose time and work. Otherwise, I was to do absolute values, right? So all right, I'll look at my inbox shift. Okay. Yes, we are doing some data sufficiency questions as well. The last five questions are all data sufficiency ones. Going into the last two are difficult, very difficult. Okay, so we will look at it. Okay, last call. I think everybody should be back. A couple of more minutes, and then we'll continue from this point. Right? Is the actual GMAT quant section the GMAT easier than GMAT club quant sectionals? How hard level questions can we expect in the quant section? Um, the GMAT club questions are slightly more difficult, I would say. Um, Again, you know, I'm more of the opinion that you always work with official questions first and then use GMAT Club, which is a great resource for extra practice, right? GMAT Club also, remember, when it goes to questions that are classified at 805 levels and so on. First is not everyone's going to see such a hard difficulty level question on test day. If you're doing really well, you would. So it's not imperative that you need to get 100% accuracy on those, right? If you get to those levels but you have a 70-75% accuracy, it's totally fine, right? But normally the questions on GMAT Club are slightly more difficult. I would only suggest using GMAT Club as a resource once the official questions are exhausted. You can still filter out official questions on GMAT Club as well. Cat is over the weekend. All the best for those appearing for it. Yes, all the best. On Cat is way more difficult on the quant section. Okay. All right. Where can we get the mixture problem video? Snigdha, I think I had taken it up when during my Crackverbal days. Look at the Crackverbal channel. Okay, you just type maybe Aditya Kumar GMAT mixtures on YouTube, and I think it should throw up, a video. Right? It's an old one, but it should work with the same principles of what you use now. Right? All right. So let's continue from here. Okay, I told you I'm going to slowly make the questions like more and more and more difficult. Okay, I may maybe skip one or two, but I won't skip the data sufficiency ones, right? For lack of time. But let's try question 11, please. Again, I've already put in the structures in place. It's how you're going to use that structure to organize your information. Remember again, reading, processing, visualizing the question becomes super critical. Spend time on understanding the data, putting in the table, then think of how you're going to piece things together. All right. Okay, you can start typing your answers in the chat window. Remember, guys, patience in reading the question and setting things up. Don't dive into calculations. Set things up, evaluate what you have, take the right call. You'll understand why now. Setting the work as the LCM will be quicker. This is just too much fractions, too many fractions to work with. You still work with fractions, right? But first, organize your information well. Okay, most of your mistakes will be because you've not read the question carefully, processed the information, and you've not organized it well. Okay, last call for answers. Okay, so let's discuss this. Okay, again, I'm going to show you how I would read, process, and adhere to those structures that I've put in, right? And as slowly as we go, forward in the next few questions, you will understand why, when I have the opportunity of taking the work to be the LCM, I would always take it because the working becomes a lot more intuitive, especially when I have more objects, when I have people moving in and out. This becomes a better way of working. Working alone at its constant rate, pump X pumped out one-fourth of the water in the tank in 2 hours. So, in my mind, when I look at things like this, it pumped out one-fourth of the water in a tank in 2 hours. So, it will pump out the entire water in 8 hours, 4 times the time. I always, in my mind, try to keep the work to be some constant. Okay. You can also write one-fourth of the work, no problem, and you can write 2 hours and you can find the rate. I tend to, look at it logically. One-fourth of the work in a tank in 2 hours. That means the entire tank should be filled in 8 hours. I try to keep the work constant across the different objects who are working. So pump X, 8 hours. Then pumps Y and Z started working, and the three pumps working simultaneously at their respective constant rates pumped out the rest of the water in 3 hours. So, what is the rest of the water? Now, who are working first? X plus Y plus Z. Y and Z started working, and the three pumps working simultaneously, X plus Y plus Z, pumped out the rest of the water. So the rest of the water is three-fourths. So it pumps out three-fourths of the water in 3 hours. So if it pumps out three-fourths of the water in 3 hours, it pumps out the whole water in 4 hours. So it takes 4 hours for all the three pumps to pump out the entire water from the tank. Next, again, observe, please. Okay, sometimes the best way to learn on questions like this, which are not very heavy in terms of concepts, even on the DI section and the data sufficiency section, is to observe how information is processed and broken down and put in an organized manner, right? So three-fourths, 3 hours. So the entire tank would take 4 hours. Now I'm going to read the next line. Say I'm not working, I'm not doing anything, I'm just translating what I'm reading. If pump Y, working alone at its constant rate, would have taken 18 hours to pump out the rest of the water. The rest of the water again should be 3/4. So pump Y takes 18 hours to pump out 3/4 of the water. So the entire water should be pumped out in 24 hours. How am I getting that? If you want to know, I'm saying I'm using the concept of proportions directly, right? 3/4 is 18. So one full would be how much? So 1 into 18 divided by 3 into 4, that is 24 hours. So why would take 24 hours to empty the entire tank, right? Now the question's asking me, how many hours would it have taken pump Z working alone at its constant rate to pump out all of the water that was pumped out of the tank? So I need Z. I need how many hours for Z. That's what I need to solve for. I have all the times to be numbers. I can set the work to be the LCM. Totally fine. So I'll keep it as 24 units. So the capacity of the tank is 24 units. So the rate of X will be 3 units per hour. This is again 24 units. Since I'm taking the work to be constant throughout, that will be 6 units per hour. Again 24 units, 1 unit per hour. Simple. Now I'm going to look at the rates as algebraic equations. I'm just going to remove this for some space. Rates as algebraic equations. I need to solve for Z. I have x is equal to 3. I have x plus y plus z is equal to 6. And I have y is equal to 1. So x plus y is 4. So 4 plus z is equal to 6. So z is equal to 2. So I have this as 2 units per hour. This is 24 units. Since the capacity of the tank I've taken as 24, so this should be 12 hours. That's my answer. B. Got it? So what did you observe in how most of y'all who gave me the answer as B? I think those who got a wrong answer of D and E, y'all would have misread. Y'all would have misread the rest, either the rest of the water here or the rest of the water here for Y. Mostly it would have been for Y. You would have missed out on the rest of the water there. You wouldn't have taken that as 3/4. For those who gave me any other answer. Okay. For those who got the answer as B, what did you observe? And especially for those who said, why do you have to use the process? Why not take the work as one? Did I do any working with fractions? Right, when I took the work, when I had the opportunity to keep the work as the LCM of the times, it was very seamless and intuitive, right? That is what I'm asking you to do. When you have the opportunity to use numbers, take that opportunity. Don't make it mathematical. The GMAT is not testing you on your mathematical skills. Okay, it's testing you more on your reasoning abilities, your reading, comprehending abilities, along with the math. All right. So did you observe how I broke it down? Right? How I read the question. When I read it, I actively read 1/4 of the water in 2 hours. So in my mind, I said 1/4 in 2 hours proportions. The entire water should be, emptied in 8 hours. Right? Okay with this? Normally, to be very truthful, since everything is pumping out water, right? You ideally should take the rate as negative. I kept it all as positive here, so it doesn't matter because all the pumps are pumping out water. But when you have a pump that pumps out water, that like a leak, right? And you have a pump that fills water into the tank, then you have to be a little careful of the sign. Okay. When you have a leak that works, that pumps out water, the rate always has to be considered as negative. Here it did not matter too much because all the pumps are pumping out. So everything would be negative. So there would not be any change in terms of my working. Got it? Any doubts on this? No? Working with fractions would also work, right? So you would do 1/4 in 2 hours. So you would do 1/4 divided by 2 to find the rate. You would do the same for the others as well. Then create those equations again using those fractions, and you would work for the same value of Z. No changes. I'm just being smart with how I organize my data and trying to get rid of fractions wherever possible. Okay. All right. Okay, let's skip this. All right. Let's give a shot at question 13. Try it out. Again, not a too difficult one, a medium difficulty question. Organize the information, be a little careful of the units as well, and work with it. Remember, the question is asking you to find the work. So don't keep the work as one, or don't keep the work as the LCM, right? It's asking you to find the work. So it's better for you to keep it as an unknown quantity X. Okay, you can start typing your answers in the chat window. For those who are wondering, why did I get a negative value? Guys, you must have not put in the rates as negative. Remember, a cistern has a leak which empties a tank in 8 hours, right? So the rate, whenever you have something that empties a tank, it's removing water from the tank. It's doing negative work, right? So the rate has to be negative. Understood? We don't keep the time as negative, obviously, but we keep the rate as negative. So anything that empties a tank, remember, the rates have to be attached with a negative sign. If you're wondering why I got a negative answer, okay? If you got some other answer, then because of the negative signs, you must have messed up slightly. Okay, so let's discuss. A cistern has a leak which empties it in 8 hours. So RTW, I have a leak that empties the cistern in 8 hours. I'm just going to put empty here so that I know I have to cater to the negative sign, right? A tap is turned on which fills water into the cistern at rate of 6 liters per minute. Since everything is in terms of hours, it's 6 liters per minute. So if it's 6 liters per minute, per hour would be 6 into 60. That would be 360 liters per hour. So this is maybe another mistake that you would have made. If you're not getting to an answer, you wouldn't have done that conversion. So remember, this is the rate that is given to me, right? So that's 360 liters per hour. And it is now emptied. So a tap is turned on, which fills water into the cistern at 6 liters a minute. So this is the tap which fills the tank. And it is now emptied in 12 hours. That means the leak as well as the tap which fills the water working simultaneously. And instead of emptying now in 8 hours, there's a delay. Obviously, you're adding water to the system, there's a delay. And that delay is of 4 hours, so 12 hours. So it takes 12 hours for the leak and the tap that fills the tank to empty the tank again. Right? This is what information I have. And the question's asking me, how many liters of water does a cistern hold? It's asking me to find out the work. So I'm going to keep that as X. I'm not going to keep it as 1. I'm not going to keep it as the LCM. I have to keep it as X. So now this is the rate, X by 8. This is going to be X. This is minus X by 8 since it's emptying. This will be minus X by 12. And again, very simple calculations. I make a algebraic equation via the rates. Minus X by 8 plus 360 is equal to minus X by 12. Right? So X by 8 minus X by 12 is equal to 360. And that's 24. 3x minus 2x is equal to 360. X is equal to 360 times 24. Right? So 24 zeros are 0. 24 into 6 is 144. 24 into 3 is 72 plus 14 is 86. That should be our answer. A. Right? Again, you see, I'm using my table. Yeah, they've given me, they helped me actually by giving me the rate of the tap that fills the tank. But see, I organized my information by reading it, right? I saw it empties. When it empties, why minus X by 12? Because it's emptying the tank in 12 hours, right? Both the leak as well as the tap that fills the tank is emptying the tank, right? So if it's emptying the tank, it's doing negative work. If it's doing negative work, I'm putting a negative sign to it. Okay. Anytime you work with questions like this, remember, guys, anything that empties a tank, you have to consider the rate to be negative. All right. Always. Right. Any doubts? Okay. Let's bump it up further. Let's make it more difficult. Yes. Let's try question 15, please. Okay. Give it a shot. I've gone into harder zones now. Okay. So again, you'll have to organize and understand and piece in your information well. Understand the pieces of your puzzle before you put everything together. Okay. Give it a shot. I'll give you 2 minutes. That's a rule, Aditya. Okay. Whenever you work with a pipe or a leak that removes water or a pipe that removes water, since it's doing negative work, you always have to consider the rate to be negative. Okay, make a note of that. For those who are saying it's confusing to read, guys, try to visualize it. Put yourself in that scenario, right? So visualize it. They are working together for some time. I don't know how much time. But A stops working 12 days before the job is done. So for the last 12 days, it's obvious, right? If A stops working 12 days before the job is done, then B is working for the last 12 days, right? Look at it like that. Always visualize when you're reading things, visualize it, right? Imagine you're part of a team, you have a teammate working, right? And this is how the question unfolds. And also remember the point that I made when I wrote down the structures. I said, whenever people are moving in and out of the question, it's always best to set up your algebra via the work. Okay? Always set things up via the work. It will become easier for you to manipulate and get to an answer. I totally understand, Ansh. Downside to my sessions are they always are long haul, right? That's the only problem. Yeah. If you feel that you're saturated, it's my advice would be log off. Tomorrow maybe you can look at the last five questions again. Good. This is a tough one. Okay, this is an actual tough one. But again, I'm linking it to the structures that I've worked with. Whenever you have a question where you have objects moving in and out of a question, learn to visualize your algebra via the work. No problem, Rohan. You can use another variable. I would have done the same, right? But then it's how you organize the information well. Got it? Okay. So let's work with it. So this is why I said, right, that this topic is more to do not with, you don't need to worry too much about concepts. It's about how you process information, how you work with algebra, how you set up the algebra. Okay, so again, I want you all to observe how I'm working with it, how I'm organizing my information, how I'm using the table. And like I said, I'm using the last point that I made in the structures. Whenever objects are moving in and out of a question, I would always want to set up the entire question via the work. So working alone, B takes 12 more days than A to finish a certain job. So immediately I would have A, I have B. B takes 12 more days than A. So let me say this is X days. This would be X plus 12 days to finish a certain job. B and A start working on the job together. So I'm going to visualize it. A and B are working on the job together. I don't know for how much time. So let's say they work together for, let's say, A days. But A stops working 12 days before the job is done. So if A stops working 12 days before the job is done, obviously if A stops working, B has to do the remaining work, right? So B has worked alone for that last 12 days, right? I'm visualizing it. I'm writing all the extra information that the question gives me to the side of my table. I'm visualizing the question. In addition to that, they've given me B completes 60% of the job. So I'm going to write that down. The work done by B is 60%. So obviously the inference that I can draw, since only two people are working, the total work done by A should be 40%. In how many days can B do the job working alone? So I need to solve for x plus 12. Right? See, I'm not getting into calculations. I'm trying to understand my question first rather than focus on the numbers and randomly do A, B, A plus B, and so on. Right? I'm focusing on what I have. I've jotted down all the information in the table, whatever I could in the table, and whatever extra on the side. Now I need the work, I need the rate, so I'm going to keep the work as 1. So this would be 1 by x, this would be 1 by x plus 12. Right? I have all of this. So I know the work of B. B does 60% of the work. So I can keep the work of B as zero point 0.6 since I'm taking the work as 1. And I know the work of A is 0.4. So like I said, whenever you have a question where objects are moving in and out of a question, always learn to use the work, right, to set up your algebra, right? I know the work done by B is zero point 0.6 and the work done by A is zero point 0.4. Let's understand what is the work done by B. The total work done by B, look at when is B working. B is working for the first A days that A and B are working together. And B is also working for the last 12 days where he finishes the work working alone. So the total time taken by B to finish the work would be A days, or the total time that B is working for would be A days where they work together plus the 12 days where he's finished the work working alone. So the work done by B, remember, rate is equal to work divided by time. So the work of B should be the rate of B into the time of B. What is the work of B given to me? It's zero point 0.6. What is the rate of B? 1 by x plus 12. And what is the time that B is working for? B is working for A plus 12. So that's my first equation. And I also know that the work of A is zero point 0.4. What is the work of A? Work of A should be the rate of A into the time that A has worked for. A has worked only for A days. That is when A and B are working together. So the work of A should be the rate of A into the time of A. What will be the rate of A? It's 1 by x. What will be the time of A? A. So this is the two equations I have. I have 0 0.6 is equal to A plus 12 divided by x plus 12. And I have 0 0.4 to be equal to A by x. And I need to solve for x. I can. The second equation gives me A in terms of x. So A I know is 0 0.4x. I can substitute that into my first equation. So 0 0.6 is equal to 0 0.4x plus 12 divided by x plus 12. I can cross multiply. I'll do it this side. So 0 0.6x plus 7.2 is equal to 0 0.4x plus 12. So 0.2x is equal to 0.2x is equal to 4.8. So x would be equal to 24. Since I've got x as 24, remember I need to solve for x plus 12. X plus 12 is 36. Tough, tough, tough question. Okay. So you'll have to organize your information well. You'll have to visualize on a harder level question. And you see what I did? I use my table. I'm using the structures. I set things up in the form of a table. Any extra information, I put it at the side. I visualize the question. And since I have people moving in and out of the question, it's better for me. And they've given me information about the work as well. It was better for me to set my algebra using the work itself. So, Rohan, you were okay by using the variable of A days for A and B together, right? But then you should have also understood that B is working for the last 12 days, right? So you had the work of A and the work of B given, right? So you could break it down step by step by step. Correct? So a difficult one, this is exactly how a tough question would look, right? You see, it's nothing to do with concepts, right? It's about how you organize your information, how you use your understanding of this topic to break things down. Remember, simple rule of thumb: whenever objects are moving in and out of a question, explore making the equations via the work. Okay. Yeah, you can do that as well, right? You can do that as well. You can immediately put this as point 0.6 when you had, right? And zero point 0.4, this is zero point 0.4 and this is zero point 0.6, right? You can do that as well. I just kept it at the side and I worked with it. And then you could have said, right, zero point 0.4 times A, right, should be equal to 1 by x times A should be equal to zero point 0.4 and worked with it. Got it. Understood. We complete 60% of the job means the entire job, right? Doesn't tell you specifically that B completes 60% of the job after A left. No. All right. Okay, so up for some data sufficiency questions, right? Okay, let's start with an easy one just to get you in the groove and not fry your brain on a difficult one, but we'll end with a difficult one. Okay, we'll do three questions. We'll do the 17s and then we'll look at another one and then the hardest of the lot. Give it a shot, please. See, when you work with data sufficiency questions, guys, don't deviate from the process. Okay, you know there is a process set for time and work. Integrate the data sufficiency process while working. What is the data sufficiency process that I've set up in the data sufficiency session? I said that it's always best in any data sufficiency question to work with your question stem, especially if it's a word problem. Right? What do? You define your variable or variables in the question stem, limit the number of variables, translate, set up the question as an algebraic equation. If it's a topic of time and work, bring in your variables in the question stem itself, organize it in the form of a table, and set up your question in the form of an algebraic equation, then move forward into the statements. All right, give it a shot. Okay, you can start typing your answers in the chat window. For those who are taking up their tests the next 5 days, right? Some of my students who've done relatively well in the last week or so. The feedback has always been that the quant section is relatively easy, right? You just have to read things a little carefully, not make silly mistakes. Um, Avoid, silly errors in the first few questions because that will hamper your score. And DI is going to be difficult, but you'll have to look at that section more in terms of how do I maximize getting a score there, right? So if you're running behind time, don't over invest. Okay, remember the best way to work with the DI section if you're running with time issues is always look at winning the war rather than winning battles with questions. Okay, so don't if you're running behind time, just ensure that you get back by maybe letting go one or two questions in between. Ideally, you shouldn't be in that position, but if you find yourself in that position, right, course correct. You're always going to be penalized for getting a continuous string of errors towards the end, okay, rather than a couple of errors in between. Okay, let's discuss. Again, like I said, principles of working with any data sufficiency question. Set up the question stem first. Introduce your variables in the question stem. Set up the question translate. Set up your question as an algebraic equation. So machines X and Y work at the respective constant rates. How many more hours does it take machine Y working alone to fill a production order of a certain size than it takes machine X working alone? Now, normally what test takers do, right, is they refrain from setting the question up here. I would not suggest that because if you spend time on setting the question, it's okay if you have to introduce some variables, right? But if you do that and you set the question up, you'll realize that the statements become very, very simple in terms of working. So again, I'm going to have rate, time, and work. X and Y work at the respective constant rates. How many more hours does it take machine Y working alone? So I'll say Y takes Y hours, right? X takes X hours. I'm going to keep the work as 1. So this rate would be 1 by Y. This would be 1 by X. How many more hours would it take Y working alone to fill a production order of a certain size than it takes machine X working alone? So what is the question asking me to solve for? It's asking me to solve for Y minus X. Always learn to set up your question as an algebraic equation, right? There's nothing more I can do with this. I'm going to go on how you got E. Okay, let's see. So I'm going to go into the first statement. Machines X and Y working together fill a production order of this size in two-thirds of the time that machine X working alone does. So what are they telling me? They're telling me the time that X plus Y take working together is two-thirds the time that X takes working alone, right? So what is the time that X and Y would take to work together? So I'm going to add the rates up. That will be 1 by X plus 1 by Y. That will be XY, Y plus X. So that's my rate, Y plus X divided by XY. So the time would be the reciprocal XY divided by Y plus X. So I'm going to write down the time here. So the time would be XY divided by Y plus X is equal to two-thirds, right, is equal to two-thirds of the time that X takes, right? So I can cancel out the X on both sides. It's a positive value. So 3y is equal to 2y plus 2x. So y is equal to 2x is what I would end up getting if I break down my first statement. But y is equal to 2x is the information I have. Is that going to be helpful for me to solve for y minus x? Remember, it is a value data sufficiency question, so I need a definite answer. Y being equal to 2x just leaves me with x, right? So I'm not able to get to a definite number. Clearly insufficient. PCE. Second, see, just translate what you have. Simple, based on the table. Translate, right? Working together, what is the time? Add the rates, take the reciprocal, right? Second, machine Y working alone fills a production order of this size in twice the time that machine X working alone does. It's spoon feeding me here. What is the time that they're telling me? The time that Y takes is twice the time that X takes. And you'll realize the time that Y takes, I've kept it as Y. The time that X takes, I've kept it as X. So they're basically giving me the same information that I had in the first statement in the second. Clearly insufficient. And obviously, when I put them together, I don't have any extra information. It's just Y is equal to 2X. Clearly not enough. Echo. Got it? Yes, both give you Y is equal to 2X. This is how it would work. Y minus X is equal to 2X minus X. How did you get that equation? Y minus X is 2X minus X. Ansh? The first statement says X and Y working together fill a production order of this size. That means the time taken by X plus Y working together should be two-thirds the time taken by X, right? So when you simplify it, you get Y is equal to 2X. And if I put this back into this equation, right, I'm going to be left with X. I will not be able to solve for it, right? It's a value data sufficiency question. I need a definite number. Having a variable means I can have any answer for that X. So clearly not enough. Make sense? Any doubts on this? Again, I'm using the structures that we've set up in a data sufficiency session. Any word problem on data sufficiency, you should spend time on breaking down the question stem and setting things up. What am I doing? I'm integrating the process of rate, time, and work along with the data sufficiency way of working. Got it? All right. Let's okay. Let's take a last question of the day. Okay. Give it a shot, please. It is a brain fry, yes. I'll give you some extra time for those of you who are trying it. Try to set it up, right? You don't need to wait for me to work with it. Try to set it up. I think it's all about understanding the question first. No answers. Very good. I see an answer here. That's a good thing to do on test day, right? If you're not able to work with it, there's absolutely no harm. I told you it's not necessary for you to get the 805, 795 questions correct. You can afford a mistake there, right? But don't let such questions derail your test as well. So that's one takeaway, right? But since if you're learning, then it's always best to break things down. Okay, I see someone has given me an answer, and that answer is the right answer as well. So great. Okay, so let's work with it, right? Like I said, I'm going to first break down the question. Okay, and that's the most difficult bit, right? If you're able to break down the question, you'll realize the statements become very, very simple for you to work, right? So I have rates, time, and work. Reserve tank 1 is capable of holding Z gallons of water. Water is pumped into tank 1, which starts off empty at the rate of X gallons per minute. So great, they've given me some nice pieces of information to start off with, right? So immediately I can say that the time here is Z by X minutes, right? So time is equal to work divided by the rate. Now, what is the question saying? Tank 1 simultaneously leaks water at the rate of Y gallons per minute, where X is greater than Y. So, whatever leak is there from tank 1, it's leaking at the rate of Y gallons per minute. And the water that leaks out of tank 1 drips into tank 2, which also starts out empty, right? Whatever is leaking from tank 1 is dripping into tank 2, which starts off empty. So this Y gallons should go into tank 2. Okay, I'm just going to write it at the side. If the total capacity of tank 2 is twice the number of gallons that remain in tank 1 after 1 minute, what does this mean? the total capacity of tank 2 is twice the number of gallons that remain in tank 1 after 1 minute. Remember, it's removing water. Tank 1 is removing water at the rate of X gallons per minute. So in 1 minute, tank 1 would remove X gallons. And they're saying that the total capacity of tank 2 is twice the number of gallons that remains in tank 1 after 1 minute. So that's two times the amount that is remaining after 1 minute would be Z minus X, since the total is Z gallons. 1 minute is X gallons, so Z minus X, twice of Z minus X would be the total capacity of tank 2. And I know that whatever leak is from tank 1 is flowing into tank 2. So that would be Y gallons per minute. So the time here would be 2 into Z minus X divided by Y. I have my question set up. What is my question asking me? Does tank 1 fill up before tank 2? Right? That means, is Z by X lesser than 2 into Z minus X by Y? I'll simplify. This is what my questions ask me. I'll simplify, cross multiply. Zy is less than 2x into Z minus X. Zy is less than 2xz minus 2x square. Right? A mistake here. So 2xz minus 2x square. Would that be right? All of you all here? Sorry, this is my bad. It should be, so the time should be what? So the capacity of tank 2 is twice the gallons remaining in tank 1 after 1 minute. So the gallons remaining in tank 1 after 1 minute should be X minus Y, not right, not Z minus Y. So this would be 2 times X minus Y divided by Y, right? So my question now is asking me, is Z by X less than, right? Is Z by X less than 2 times X minus Y divided by Y, right? Yes? Any doubts on this? Let's break it down. For people who are not understanding how I'm getting this, I'll break it down again. Remember, I'm going to keep the capacity of this tank as Z. Okay, let's break it down slowly for all of you all to get this. I'm keeping the capacity of this tank as Z. It's given to me. Now, what is the question telling me? X, there's a leak. That leak is flowing into tank 2, where X is greater than Y. So the water that leaks, so the net filling rate of tank 1 would be X minus Y. So the rate here would be X minus Y, because what's happening? I have Z gallons. The rate is actually X gallons. Let me put it this way. The rate is actually X gallons to start with. But what's happening? This is X gallons per minute. Every minute, Y gallons is going into tank 2. So the overall rate of tank 1 should be X minus Y, since X is greater than Y, right? Gallons per minute. So what would be the time that tank 1 would take to empty? That is Z divided by X minus Y. Now let's take the second bit. What does the second bit say? The water that leaks out of tank 1 drips into tank 2, which also starts out empty. So whatever Y gallons are going here, it's coming into tank 2, which starts off empty. If the total capacity of tank 2 is twice the number of gallons that remain in tank 1, what is the number of gallons that remain in tank 1? X minus Y. So the total capacity should be 2 times X minus Y. Remember, this is what will remain after a minute. If I take a minute, Y gallons is removed. What I'm left is X minus Y. They're telling me the tank, the second tank is twice that capacity, 2 times x minus y. And what will be the rate? The rate here has to be y gallons itself, because whatever is flowing from tank 1 has to come to tank 2. So what will be the time here? 2 times x minus y divided by y. So what is my question asking me? Does tank 1 fill up before tank 2? So is z by x minus y less than 2 times x minus y divided by y? So zy is less than 2 times x minus y the whole square. So zy is less than 2 times x square plus y square minus 2xy. So I'll do it this side. Is zy less than 2x square plus 2y square minus 4xy? This is what my question is. I've broken my question down. Now it becomes easier for me to process. The first statement gives me exactly what I want, right? Without any problems at all. But what does the second statement give me? The second statement says the total capacity of tank 2 is less than one half of tank 1. So the total capacity of tank 2, which is 2 into x minus y, is less than one half of tank 1. That's half of z. So 4x minus y is less than z is what I would get. 4x minus 2y, or 4x minus 4y is less than z. But this is not going to help me out because this is the equation that I need to solve for. Clearly insufficient. Alpha. Got it? A difficult one to work with, right? So you have to set the question up very well. Understood? Yes, this is definitely a hard question. Something in the range of a 705 or 805. I mean, not even 705, I would say 795, to 805. This is a hard question on the test, okay? Because you'll have to visualize and you'll have to understand how to organize your data. Make sense? Yes, for 1t should be z divided by x minus y. Can we use this z in the other inequality? But remember, I need to prove whether zy is less than this, right? So the question is zy less than 2 into x minus y the whole square? All I know is 4 into x minus y is less than z, right? How do I know? I can say I can maybe square both. I can't square both sides also because I don't know which side is greater than which, right? So I don't know what to do from this point. All right? Make sense? A tough one. So, like I said, right, you'll have to take a call if you're able to break it down. But when you see a question like this, immediately you see it's too convoluted in the beginning, let it go and then move forward, work with the remaining. Okay. Don't over invest on such questions. Immediately when you see that, you've taken the DI, so normally people take the DI section towards the end. Immediately when you see that, okay, it's going to be a time sink, I'm completely exhausted already. It's better for me to choose to let go, put my weapons down, let go of this battle, and try to work with the other battles that I am capable of winning. Got it? All right. Yes, it will. It will. Okay, it will. So you have to understand that questions on the DI section will normally take you a good part of 3 minutes and so on. So you'll have to be very very efficient. Okay. So if you get something like this, guys, quickly take a call. Work with something that's more doable. Don't let such a question impact your overall so letting go of this harder question is absolutely okay if I'm able to get the other questions that follow right. All right. Okay, so this is what I had. I have another question, but I think it's already been 4 hours and I don't want to put you through another torture of a hard one. So what should be the average time spent for the DS section and DI? um it would differ for student from student to student, Ishan. What I normally suggest to all my students is when you're working with the DI section, um, work with each of the question types first to understand how much time you are taking on average on an MSR, on a two-part analysis, on a graphical interpretation, table analysis, and finally on a data sufficiency. Okay, so based on that, try to figure things out. Ideally, the time you need to invest in a multi-source reasoning question should be around 7.5 to 8 minutes, because you'll always have three questions that fall under that. A data sufficiency question should be in the cusp of around 2.5 3 minutes at most for a difficult one. A two-part analysis also should be around 3 minutes, and a table analysis also should be around 3 minutes. Okay. Ara, nothing else other than focusing on the marks. Okay. What I would do, Ara, I would also maybe sit down for maybe an hour or two, and I would write down what are the good habits that I want to promote on test day, and what are the things that I have to be aware of, right? That I normally, make mistakes on. Okay, sometimes on data sufficiency questions, people don't write constraints. Sometimes they read the question too quickly, so silly errors crop up. So sit down and write down what are the things that you would want to execute on testing, right? Things that you would want to do and things that you would want to avoid doing, so that you're aware of it. If I were you, I would just do timed practice sets, one for quant, one for verbal, one for DI. Analyze those practice sets and then take maybe one test, okay, in the next 4 days. I wouldn't overdo it more than one. All right. Aditya, the last question, if you use the inequality using z from the given values, you can also derive answer from the second statement. How would you use that, Rajat? So can you type in your process of working, right? So what do you have in the second statement, right? You have, just looking at your message, so 2 into x minus y is less than z by 2, right? Is based on what we set up, right? And what was the question? If I remember right, is xy zy 0 only, right? Is zy less than x minus y the whole square? Correct. By 2, I think it was, right? So the question was, is z less than 2 into x minus y the whole square? This is what the question is, right? This is what I have. I'm not going to write everything down. So from here, how do you get to here? Tell me that. Raja? I've got the second statement as 2 times the total capacity of tank 2, which is 2 times x minus y, is less than one half the capacity of tank 1. That's less than z by 2, right? So I have basically 4x minus 4y is less than z. This is what I have, right? So from here, how do I prove this? Remember, it's a yes/no data sufficiency question, correct? So how do I definitively say? It's not about, okay, I think I understand where your mistake comes from, right? I think what you're doing is you're taking that equation and you're trying to plug it in and you're seeing if it satisfies it. That's not how you work with the yes/no data sufficiency, Rajat, right? Your job is to see whether this information is enough for me to answer the question definitively. That means I should be able to answer the question with a definite yes or a definite no. With this, I should be able to answer whether zy is always going to be less than 2 into x minus y the whole square, right? So if I do this, right, 4 into x minus y is less than z, right? From here, I can't go and substitute that. Remember, this is an equation that I have to prove. It's not an equation that is given to me. So I have to use this information and see if I can definitively get a yes or definitively get a no. I can't use that to answer, right? I don't know what the values of x, y, and z are. Different values of x, y, and z, that satisfies that statement, may give me a yes here, may give me a no as well. Right? 2 into x minus y the whole square is greater than zy. Okay. Is greater than zy is greater than 4x minus y divided by y. Okay, so I mean, this is an inequality sign, no? So where did the inequality sign go? You substituted for y. You substituted for z. So 4 into x minus y. Right? Now explain this to me, right? So you got 2 into x minus, okay, you written 2 into x minus y the whole square is greater than xy, right? Is greater than zy, sorry. And then you also said that zy is greater than 4 times x minus y by y. So you divided both sides by y is what you're saying? Can you divide both sides? Can you divide both sides? Okay, so you divided both sides by y. So you're saying z into x minus y whole square by y is greater than z is what you're telling me, correct? And you're telling me z is also greater than 4x minus y. Yes? In an inequality question, you don't divide. In an inequality question, you don't divide by x plus x minus y, right? I don't know whether x minus y is going to be a positive value or a negative value, no? If I divide x minus y, if x minus y is positive, Rajat, then I would keep the inequality sign the same. But if I'm dividing both sides by x minus y, if x minus y is negative, it will flip the inequality sign. Correct? So I know x minus y is greater than 0. So you have 2 into x minus y the whole square is greater than zy is greater than 4x minus y divided by y. So can you explain this? How are you getting 2 into x minus y the whole square is greater than zy is greater than 4x minus y divided by y? Like I said, right, this is the question. What this is here is a question. It is not a definite piece of information that you can use to manipulate the equation. It's like me asking you, is my name Aditya? I can't take my name to be Aditya and work with it, right? Understood. This is not a definite equation that is given to you. This is something that you have to prove. So taking that and working with the definite piece of information that you have is not going to be the right thing to do, right? What you can do is, you know that the total capacity of tank 2, what is the total capacity of tank 2? The total capacity of tank 2 is going to be 2 into x minus y is going to be less than z by 2. This is the definite information that you have. What you can do, if you want, you can take this and you can substitute in the equation and you can transform the question. But if I transform the question, right, I'm still unable to say whether the left hand side is greater than the right hand side. No, if you take the value and see, you're going to get 4 x 4 into x minus y is less than z, right? So if I have 4 into x minus y is less than z, this is not a definite piece of information for me to take and substitute and work. Okay, you have to understand that that's the question. If I have a question, I cannot treat it as a definite piece of information and manipulate it and try to work with it. Make sense? I'm saying, say 2x minus y the whole square is less than zy. Okay, and then use the equation, you will get x is less than y. Okay, I think it's better for you to maybe put in write down your entire process of working, send it to me over email or in the chat itself, and then maybe once I see your way of working, I can give my comments on that directly. Okay, that would be a better way because in my mind, what I think you're asking, I understood what you're saying by contradiction, but I would still not use that as a definite piece of information and reach a conclusion based on something that I have to prove. Right. All right. So send it to me, please. My email ID is there on the GMAT Club channel itself. So you can send out an email with your working, and I will respond to that. I will write my comments on that as well, and we'll work on that. Okay. All right. You can actually maybe I'll do it in your working. You can take a couple of examples that satisfy this equation with numbers, and then work towards your question. Right? I'm sure you'll be able to form two counter examples, one which answers your question with a yes, and one which answers your question with a no. Okay, so send me um, your explanation. I will mark where it's wrong, and I will also maybe put in a couple of values to prove that to you. Okay. All right. Last call, guys, for doubts. Anybody want to ask me something towards the end? It's there on the GMAT Club. Any of the videos you see, there'll be my ID there. You can just have a look at it and send it to me. All right, guys. All right, Ishan. Okay. Thank you so much for staying up. Right. I know it's been late. It's, 4 hours. It's not too easy for you to sit down. So I'll have my last session in maybe a 3 to 4 weeks of time. I'm yet to decide what to do. I may opt to do maybe an absolute value or some other topic. So I'll let you know in due course what the topic would be. But thank you for attending the session, and hope to see you in the next session as well. Good night. Have a great weekend.